Okay, guys, good morning. Welcome back. We were working on string functions, right? So what I've done is, you don't have this from last week, but I've updated it on Blackboard. I thought instead of typing it in class, I'll save myself maybe 5 minutes, so I'll put it here. Again, I repeat, this is not the end of string functions. All I'm doing is I'm introducing you to string functions. So you could be asked any functions. We've seen a couple of date functions. Remember year, for example, there is a month function also for your information. So I can't do all the functions. It's impossible to do them, each one of them in class. But the aim is that you get the knack of it, that there exists something, right? So all you do is you go to the manual whenever you have an exam or an assignment. On assignment, you're open to kind of Google it and kind of get the answer. But during an exam, you're allowed the manual. So you can kind of go to the manual and look for string functions, date functions, numeric functions, and then guess from there. You know, when I say guess, I mean an educated guess. So you can look at all the mathematical functions and one that makes sense to you. We did cast, we've done round, we've done truncate. There is a ceiling, there is a max, there is a min. There are so many functions. So what I've done here is, we were talking about this substring function last week, where I said the substring, there is a function called substring for your information. There is another called substring index, and the substring index kind of works this way, that you can say, oh, where do I want to, what am I looking for basically? What am I looking for and what do I want to do? So numbers can be positive or negative, 1, 2, 3, whatever can go. All it is doing is leave 1 from the left, the first from the right. 2 means the second from the left, second from the right, and so on and so forth. Right? So what I've done here today is I've kind of given you, oh, is that the only way you can do it? No, there is another way. So I kind of commented this out because I didn't want, the aim is just to show you how the in string works. And again, as the name suggests, in string. So what you're saying? You're saying, I want to find out where this comma exists in my table donations when I pick up the recipient field. So this is just to show you, and then I'm using it here, and therefore I kind of placed it. So anytime you want to check what a function is doing, the best way is kind of work it out. Like what I've done here is I've said, okay, so I'll run it till here, see what it will tell me. So I'm saying, where does the comma occur in the recipient field in the table? So here, so it tells me, okay, so the comma is occurring at position number 13, position number 22, and position number 13, again in the recipient field. Now, it's not important. I didn't change the headings here because, as I said, this was just to show you how it works. Headings definitely make sense when you're showing a table and output to the user. They definitely make sense, right? So what does in string do? If you can kind of make an educated guess, it's saying, where do you find the comma? At what position do you find the comma in the recipient field? That's what it is saying. So instead of using substring index, which is a kind of a combination of both, it says, go to the recipient field, look for the comma and give me 1 to the left of the comma. So what I've done here is I've given another way of doing the same thing. What did I do here? I said, so notice I've used 3 functions in the same statement. I've used an in string function, I've used a left function, and I've used a trim function. So you can nest functions to any depth. A function inside a function inside a function, as long as you know what is the function returning and what do I want to do with it. So function has a name. A function has some arguments or sometimes no arguments, maybe 0 arguments, 1, 2, 3, it depends upon the function. And then it may or may not return a value. So it may not return a value. That means it gives nothing back to you. It does something. It may return a value. Max function returns you the maximum value, right? So what have I done? Look at what I have done, kind of one step at a time. I find out where the comma is occurring in my recipient field. So let's take an example. If I wanted to break my name and it was written like this, right? So I'm saying look for the comma. The in string function gives me the position. So 1, 2, 3, 4. Oh, we'll have to check whether the position is from 0 or 1, but that doesn't matter. But logically, 1, 2, 3, 4, 5th position, right? So it says, what is the position of this comma? 5. It says subtract 1 from it, so 4, and pick up the first 4. So Anju will come out of it. So what does the left function do? Left function takes from a field certain number of characters from the left. Right function takes certain number of characters from the right. And the mid function takes it from a particular position till the end of the string, or if you only want 4 or 5 or whatever. So these functions, as the name suggests, left will pick up something from the left-hand side, right from the right-hand side, mid from the mid side. You'll say, how can I remember all this? You don't have to remember all this. All you do is you go to your manual, which you by now know what they are. So look up for the string functions, for example, in the MySQL. So let's look for the manual. And here somewhere I'll find, not somewhere, I mean, if you go down, you will find the left function here. Click on the function and notice what it says. It says returns the leftmost len characters. That means those many, 4 characters, 5 characters, whatever characters from the string str. So here the name of the function is left, takes 2 arguments, str and len. String is the string in which you are looking for something. Here I'm looking for the recipient field. So it's a string, varchar. String means varchar, right? It could have been Anju, my name. I could have put my name right there. And then, or null, if any argument is null. Any argument null means maybe the string is null or the length is null. So if I kind of, just for the heck of it, put this here. So example, let me do it. I say, let's do it. I say select, right? I say select in string, left. And it said it will select some characters from your name or whatever. So I'm going to do it for my name so that it makes sense. So I'm going to take my name, Anju, Chawla. Oh, caps lock is on, which is not a big deal, but anyway, I'm just doing, I can do a blank if I like. Here, let's do a blank, right? So here is my string. So from this string, I want to pick up my first name, but first name could be different. Anju is 4, right? But Malika is not 4, and so is Kayla not 4. So I don't know how many, but I know after my first name, I have a blank. That I know, that between my first name and my last name, I have a blank. So what will I do is, I will search for the blank in my name. So here I'm kind of making it specific to myself, but so in my name, I'll search for blank. So now I'm using a string. Instead of using a field, I'm using a string. So as long as it is a string. And in there, I'm going to look for blank. So blank. I'm looking for blank, right? So quotes, blank, space bar, blank, right? Now, why did I do a -1 from it? Because it gives the position. So 5th will be my position. So I want the first 4, right? And then of this in string, I'm going to subtract a 1 from it. And then apply the left function. What do you think it must return to me? Anju, right? So one at a time. The in string function returns me the position of blank. From that position, I subtract 1 because I don't want to include the blank. If you want to include the blank, leave it alone. And then I use the left function to extract these many characters, len. Remember we said len. N is for how many? How many? How many characters do you want? The len is how many characters? Leftmost len characters. So the leftmost 4 characters will be extracted and will be put on the screen. So if I just take this statement and I run it, just this statement, it has nothing to do with the table. There it is, Anju. Do you see? That's what it has done. So that's exactly what I'm doing here also. I'm taking the recipient field. I'm looking for the comma. I subtract 1 from it. I have to know the format. I have to know the format of the field. Otherwise, I can't do nothing. So you have to know. You'll say, but you told me never to peek in the data. But when you're doing some functions, especially string functions or whatever on data, you have to know how the data is organized. Otherwise, how will you know? If I say, oh, student's name is first name blank, last name, then you know it is separated by name. So you have to know that information. So I know that information that there is a comma. I find the position of the comma. I go -1. I find out the left and I trim it. Remember, there were many blanks in front and back of fields. So I said, if I don't do it, I'll have an untidy output. If I do it, then I have a tidy output. So I've used another 2 functions there. I've used in string and I've used the left, and the trim is just to remove the blanks. So again, just some examples for you. And I kind of added a right example to tell you that, oh, a right also exists, though, I mean, it's not a, I mean, it was just out of the, for every field, if you want to pick up the first 4, the rightmost 4 characters, this is how you would do it. right? So again, how will you know about them? Every time you need something, you will have to look it up. So a general idea will help, and it helps if you are familiar with other languages. But if nothing else, you can always say string functions, MySQL, open them up, go through them, and kind of there's a small definition of every one of them, and there you are. Right. So again, I mean, my aim was just to show you that there are more functions. Now I've used left and mid because they were easy for me. I said, now look at what I'm doing here. I find the comma, I add a +1 to it. So I go to the next word, right? And then I say till the end. Give me everything the end. So mid works that way. I don't know how many characters, but if you kind of look at the mid function, if you go and look at the mid function, so everything, all information will be here. I mean, somewhere here. So I'll go back to the main table and let's look for MNOPQRS mid. Returns a substring starting from the specified position. So here it is. Notice it has 3 parameters. It says is a synonym for substring. Oh, it works the same as substring, it says. So if I click on substring, here is substring. It says, okay, now there are a few options. There are many versions of these, but the one that we have to pick up is this one. So in this string, it will start to look at position this for these many characters. And if you miss out the length, if you miss out the length, it will automatically go till the end of your data. So that's what I did with mid. I didn't know Chawla has 6 or 5 or whose ever left name, I don't know, but I know that it starts after the blank. So after the blank, all I said, give me the rest of it. So try it. Try in this same thing that you did left. Let's try the mid now. I cannot use right here because I don't know how many. Let's try this. Do a Control V. Now, instead of using left, use a mid. And I don't know how many. So all I'm saying I'm saying start at this position, but I'm not saying how many. I've missed out the third one. I don't write my third parameter because I don't know how many. So therefore, I can't use right. I have to use mid. Right only in right, I have to know how many do I have to pick up. In mid, I say where do I start? And if I don't give the third parameter, till the end. So now I should go Chawla with from here, right? So look for the blank, add +1 to it because I want to start after the blank and give me everything till the end of my Chawla, of my name. So try this one now. So select is an easy way. If you want to do stuff, you just do a select statement. I mean, that's the easy, it's like an out, see, there is my name. Right now, I cannot do right here because otherwise I have to know Chawla has 6, I know, but if it was you say, oh, change the name, like recipient could be anything, right? I don't know what's in the recipient field. I just know there is a comma, there is something before the comma, and there is something after the comma. So before the comma, I get from the in string left, and after the comma, everything till the end, I get from the mid function. So I cannot use right here. Right is only useful when you know how many do you have to pick up. Like here, you knew how many you have to pick up. You're saying pick up these many. This is the number of characters. How many? And this is saying where do I start? Right? So again, they're available. So my aim is just to let you know or make you aware that there are functions and you've seen them here. They're all here. So anytime in an exam or in an assignment, you need a function, you'll have to go up, look up here, and it's not too bad. They're all they help. Right? If you kind of look at it, they help. And you kind of say, oh, maybe this will work for me. Maybe this will work for me. Click on it and look for it. So here is the right one. And here, right, we have to know how many. And when it says or null, if any argument is null, it returns a value of null if any of these parameters are null. What it means is if you put something like instead of 4, you put the word null, the answer is null. Which is odd. Why would you do that? But sometimes you don't know what's in the field. Here they have foo bar, but I don't know, maybe the recipient field is null. So you're saying pick up from the null field the rightmost 4 characters. All it says is the return value is null. That's what it means by saying or null if any argument is null. That's what it means. So when you don't know what's in the field, then you don't want the program to break or stop executing or give an error. This one is not a bad one at all. It returns null. You know, oh, if null is returned, nothing exists. So you can always check if null is returned. Okay. So I kind of completed this just because I wanted to save time. And it just takes more time typing. And I gave an example of trim of right here so that you see it. So choose whatever you like. I mean, of course, you won't do all of them because you've already done writing. But I mean, you will have, the double the work, but the answer will still be there. So if you run the whole script, It should still run as it was running. And you should see the writing and whatever in there it is, Berry, Liberal Party, whatever. And I dropped the recipient field after that. And usually that will be the case. When you are adding new fields and you want to kind of get its data from other concatenated field, you'll drop that field after you do this. You'll say, oh, what if I want to bring it back? All you will do is concatenate it. Take your writing, take your party, use the concat function. And if you have to spit it out, spit it out. Right? Why would you keep both the fields? You never keep duplicate data. It's a very bad design. If you put redundant duplicate data in your table, you say, oh, let's keep the recipient field also. It's together. No, you shouldn't do it. It's not a good principle at all. Why would you do it? Okay, because you can always get it back. If you wanted to, you could always get it back. So I've dropped the field, but if I wanted to kind of look at it, I can always do this. Nothing stops me, right? You have a select statement. You can use your concat function on your, what was it? Something and writing, right? Party and writing. Yep, writing and party, right? So take your concat, do your writing. If you want to put a comma, nothing stops you. Put a comma and a blank and then concatenate it with party. And then spit it out. And again, definitely when you do anything like this, always give a heading. You can say something like writing comma party. You know what I mean? Like it's an odd one, but constituency or something. They call it something like that. What was it called? Recipient. But I think that's what it is called. I'm not sure. I'm not a political person at all. I have no clue. So I'll just kind of, again, bring it back to recipient just because that's what it was called. There. So anytime I want to see it, I can, nothing stops me, right? So I'm just running it again because I'm not sure if I made changes or whatever. There it is. Much more neater, of course, right? Don't I see a comma? Yeah, okay. Simco not. Oh, now just let me point it out. Simco not, there is no way of removing the extra blanks. Trim doesn't remove blanks from the middle. You say, is there a way? Yeah, you can. Find out the first blank, do a left, get Simco. Then for the rest, kind of do a right from whatever. I mean, it can be done and then join them together. I mean, you'll have to do a little bit of coding, but as such, there is no inbuilt function that removes blanks from inside the data item. It says, why do you need to do that? I mean, we understand extra blanks on the right and the left make no sense, but if you put blanks in between them, then you need them, kind of. So in this one, I can do this. I can find the first blank from the left. I can find the first blank from the right. Now I know their positions. I know how many blanks in between. Then I can just subtract that starter mid and do that. I mean, it can be done. It's just a mathematics. It's just a little bit of math in your head and you can do it. But I can't by it inbuilt. Trim doesn't do this. Trim only removes right and left. So I have used trim. Some of us may not even remember to do it. But when you see your output and it looks untidy, you say, oh, I think I better trim it on the right and the left. So maybe on the first go, you don't even think about trimming your data. And that is why when I was giving you this example last week, I said, don't worry about all this untidiness. I did it. I wanted to show you extra blanks in front, back. And of course, this one, which I cannot remove. And you can put blanks anywhere you like. We've taken care that they're all trimmed, right? So the bottom line is that there are many functions available, many inbuilt functions available with different data types, strings, numeric, date time in MySQL. And as and when you need to use them, you will use them. Okay. So that's it for strings. I'm not doing more. I could not, just because I only have 3 more classes left. Otherwise, you could devote 10 classes to string functions. As I said, there's no end, right? You could try one with everyone. So keep that in mind when you do your assignments or your exam. I thought I had made up an assignment, and today morning I spent 1 hour looking for it. I don't know where I've placed it. So I did make an assignment on strings and I can't find it. I have no clue where I have saved it. Like, I can't even remember what I called it. So I've been trying it since morning today. For an hour I did it. So if I get it today, I'll post it on Blackboard. If I cannot, then maybe you'll be assignment less than what you were supposed to get. I'm not putting in that effort again. I can't even remember where I placed it. But I did create one on string functions, just because it is a little bit of practice, nothing else. Now, today's job. So I'll save this and I'll put this back on Blackboard if you want. Now, your job is that you pick up the 2 files that I've placed on Blackboard for today. Right? So today's date is February 26. Under weekly learning, you will find 2 files. My contacts, I think one is called, and one is called My Contacts Jobs 2. So 1 and 2, just because, I mean, it's the same file, absolutely same file, but I want to show 2 things, 2 different things. Inbuilt, what is available, and what we can do on our own. And that's why I've created 2 files. Pick them up and get them on and open them up. So they're on Blackboard, okay? And this one I'll place when I finish it. So I'll open it too. So winter 28, February 26, My Contacts Blackboard 1 and My Contacts Jobs. So that's the first one. You have these on Blackboard. So pick them up, please, and open them up. We'll do one at a time. I'll do the first one. I should have called it 1, but then I said, oh, it's the same file, so I called it 2. And jobs 2. Now, a very important concept. You'll learn a very important concept today in databases, which you will see almost everywhere. And I want to explain it to you, and then we will go and kind of complete this. So it will take some time. Have patience. Joins and subqueries are the most toughest topic of this course, right? Because now you're not going to deal with a table, but you're going to deal with more than one table. So it's kind of it will take time. So therefore I've given it 3 weeks, right? I give it 3 weeks, sometimes 4 too, and I practice as much as I can with you. Like I'll do as much as I can in these 9 hours, okay? And of course, I'll give you an assignment and I'll give you some practice questions also. Okay, so let me save this so that I have a copy. Let me save it as classwork. Okay, so let me introduce you to the second normal form in databases today. Now, we've talked about first normal form and we have been using it. A table is said to be in the first normal form if it has a primary key. 1, that's its first condition. And 2, there are no repeating groups of data, or in other words, it's also said that every field is atomic in nature. It cannot be broken down. And when I say cannot be broken down, there is a kind of a underdefined definition with it. It need not be broken down or cannot be broken down. So as I said, an example of name. If I need to, if the application needs to have first name and last name in different fields, atomic fields, I'll put them in 2 fields. But if the name is just a name, it's not so important. It's, for example, you are ordering pizza. I mean, they're not concerned about your first name and last name, but a bank is. They'll keep it in 2 different fields. But if you're going to make an online, order for pizza and it says your name, they don't keep it in first name and last name. It really is, to them, it's not even important. Even your first name will do. There, the field could only be a name, right? So when I say every field is atomic in nature, underlining, I'm saying that atomic nature means it need not or cannot be broken down into more fields. It also has another definition. If you look it up on the web, it says there should be no repeating groups of data in the same field. And a good example of that is your favorite sites, the first example that you did. When you said favorite sites, I said, okay, just let's create a 100 varchar field and favorite site 1, comma, favorite site 2, comma, favorite site 3. This is supposed to be a very bad design. Why? Because the first thing is, how many are you expecting? Maybe one person says 2 favorite sites and the other person says 10 favorite sites. So, and then if you're going to see, oh, whose favorite site is, say, example, google.ca. That means you will take up that big field, then you will extract google.ca from it, and then you will see the result. Now, of course, if you had kept these favorite sites in different fields, favorite site 1, favorite site 2, favorite site 3, and so on, then it was easier. But again, that's not even the best answer to it. Oh, let me make 10 fields. What if somebody only uses 2 of those fields, right? So that's the first normal form. So all these anomalies, what do I do with repeating data? Atomic is not so difficult, but repeating is something that you have to keep in mind. You go to creating more than 1 tables. So you can't think of a good design for a table you will create a new table for it. And let me kind of give you with favorite sites because it's coming up so much and it's kind of easy. So suppose I had a favorite sites field, and I'm just kind of saying site1.ca. I'm kind of just writing it so that it's easy for me to break it up. And so on. So these are your favorite site fields, right? You say, oh, now somebody has 3, somebody has 2, 1. What do? Do I make a varchar 100, 200, 250, 50? No idea. And then if I don't even know how many. So what I would do, you will say, what do I do with this? I will create a new table. And that new table, all that new table has in it is, I'll call it sites or something, right? It will have a site name, for example, and it will have an ID that is unique. So for example, s1.ca has an ID of 1, right? s2.ca has an ID of 2 and so on and so forth. So a table is created in which all possible, you say, now how is that possible? How will you keep all possible favorite sites? And this is assuming we are talking about semester 1, I'm only talking about PHP course or my own course, and I know these are the favorite sites, right? So you have to kind of narrow it down. So I'll create a table. Now, this table is already created for a student. It has student name, student ID, and so on. But I remove this favorite sites from here. You say, then where is that information? That student number 1 likes S1CA, S2CA, and S3.com. Student number 2 only likes S1.ca. Student number 3 likes S2.ca and S3.com. Where will you keep this information? You don't lose information. A new table is created. In that new junction table or intersecting table, you will keep this ID, which I just call SID for now, site ID, and we'll keep this ID. Right? And what will I do? Student number 1 likes site number 1. Student number 1 also likes site number 2. Student number 1 likes site number 3. Right? Next, student number 2 likes site number 1. Student number 3 likes site number 2 and also likes site number 3. So from one table, you will have to break your tables and create 2 new tables. One table that keeps all the favorite sites, and 2, a junction table. See, it's related. It's an intersecting table because it has picked up the ID from here and it has picked up the site ID from here. So, oh, you're complicating things instead of making it easier. I'm not complicating things. I'm making a good design, a foolproof design. That's what I'm trying to do. And the aim is not to just do something. The aim is to do it right because these databases and these tables have a life of years and years. So you just can't start with a bad design and say, oh, if I need this field after 1 year, I'll just add it without even thinking. Oh, I need another field, I'll add it. That's not how it goes. So therefore, I mentioned a database designer is a complete job in itself. It's a different entity. So you have database administrators, you have database designers, you have database programmers. So in this course, you are trying to learn programming, right? But that doesn't mean you should not be aware of the minimum requirement of design. So I'm trying to introduce you to design issues as well, and also teaching you programming. So one normal form, we've been kind of doing it these past 4, 5, 6 weeks. We've been sticking to normal form 1. Today onwards, we will also start doing normal form 2. Normal form 2 says a table is said to be in the second normal form if it is in the first normal form, for sure. That's done. And 2, a very important property says, I'll write down these definitions for you, but you can always look them up. And the second property says that there is no field in my table that is only partially dependent upon the key field. So we'll look at examples and then I'll kind of make it more obvious for you. And I'll put an example of all normal forms for you, which I teach my programmers also. So today, starting today, you're going to deal with more than 1 tables. And the reason of, can a database have more than 1 tables? Definitely. Think about Georgian College. Now, Georgian College has these entities. Students, there will be a student table. Teachers, there will be an instructor's table. Part-time staff, there will be a part-time staff table. They won't put all information about everybody in one big table. It's impossible because your fields or your information is different from what information they would like to keep about P. Date of hire makes no sense for you. Student ID makes no sense for me. courses that you take, your semester number makes no sense for an instructor. Similarly, administrative staff. These two entities, lecturers or instructors and administrative staffs, are very different, right? So they can put everything in one big table and say, here is my database. They will create different entities. And therefore, a database will most probably, mostly in 99.9% of cases, have more than one table in its database. So till now, we have been talking about the 0.1%, only one table in the database. But today onwards, I'll start talking more than one table. And think about it. Suppose I want to keep this information that which student is taking which course. Where will you keep this information? If you start keeping this information in the student table, think about student 1 is taking Comp2003. And the student 1 already has all additional information, name, email ID, address, phone number. And now the student 1 is also taking some other course, say math 1003. And again, all the information about student 1 is repeated. Ridiculous design. The student information, you don't have to repeat the student information in every record. If the student is taking 6 courses, the student information appears in six records. Ridiculous. It's a poor design. Logically think of it, it's a poor design. So what will you do? You will remove this information from here. Student table will be one table. Courses table will be another table. Comp2003, all courses that are available with a proper ID, 1, 2, 3, and so on. And now the combination. Student number 1 is taking 1. Student number 1 is taking 2. Student number 2 is taking 3. Student number 3 is taking 1. Student number 3 and now you will have a junction table, a combination. So when you design tables, which is not what you have to necessarily learn in this course, but you must have a good understanding of, because in the long run, maybe you'll be doing, a small company won't hire a database designer and a database programmer and say, here, I pay both of you separately and now you make a design. It will be almost your job in small applications. So you have to understand that creating tables, how should you create tables? So instead of keeping all information about students and the courses they are taking in the same table, I'll keep student information in one table. I'll keep the course information in another table, and I'll create a junction table or an intersecting table that tells me which student takes which ID. And notice I only keep the minimum information. ID is that small part which uniquely identifies a student, and course ID is that unique part which identifies a course. Of this is the primary key, right? Your student number. Of this is the primary key, your course ID number. What do you think is the primary key of this table? Combination of both. Because unique, the togetherness uniquely determines what are you talking about. And there will be no repetition. 1, 1 will only occur once. 1, 2 will only occur once. You won't repeat this information again. So of this table, the primary key will be a composite key. That's another thing you'll have to start learning today. That every table may not only have a field designated as the primary key, it can have a combination of fields designated as a primary key. It's still a primary key. Every table only has a primary key. But that primary key could be a single field, it could be 2 fields, it could be 3 fields, 4 fields, or worst case scenario, all fields of the table. Which in our case is happening, we only have 2 fields. Right? So that's called a composite primary key. So a primary key can be composite in nature. So today onwards, till the next 3 classes, we are talking multiple tables in a database, and we may or may not be talking composite primary keys. Some tables may still have single, some may have more than one. Now, a third question that I would like to ask of you. Can you tell me the nature of these student IDs and the nature of these, or the rules or the nature of these course IDs? Can I put something like 4 here for a course, and that course does not exist in the course table? Logically think about it. Can a student take a course 4 when the 4 is not in your courses table? Can it happen? No. Vice versa. Can I have a student called 4, ID 4, if the student is not present in the student table? No. That means you have to have some other kind of a rule here. So this is a junction table, but the rule is that the values that are occurring in this part of the key, the student ID, must come from this table. And the values occurring in the course ID must come from the course table. Otherwise, like it can't happen otherwise. You know what I mean? It's illogical. This kind of field that draws its value from another table, and the restriction is you can draw it. That's the only possibility. You can't have anything extra. This kind of field is called a foreign key. Why foreign? It's taking its value from somebody else. So you will learn about foreign keys also now, right? So when multiple tables exist in a relational database, there may or may not be relationships amongst them. One, the primary key of a table may be a single field or it could be a composite field. Two, and when you have such kind of tables existing in your table, and therefore it's called a relational database. There's a relationship, right? Student ID, course ID. And when such type of tables exist, then foreign keys will exist in the table. So now our aim is how to define multiple tables, how to define primary keys that are composite, and how to define foreign keys. So these three new things we will learn how to do in create table command, right? And then once we have more than one table, then I say now start answering queries, now write select statements, then you have to think, oh, I want to pick up some information from this table, I want to pick up some information from this table, and I want to combine it together. So for example, I say, can you tell me, is Vivian taking a course 2003? So what I have to do? I have to find, okay, so Vivian's ID is 1, right? I pick it up from here, I come to that table, 1. 1 is taking 1 and 1 is taking 2. Is either a 1 or 2 Comp 2003? I go back to that table. Yes, it is. Oh, she is taking relational database. So you will have to kind of select from 3 tables to give me an answer to a query. So we'll have to learn how to join tables to answer queries. So everything stays. Your select statement, select from, where, everything stays. Group by, having, order by, limit. Its nature doesn't change, but the from changes. Instead of drawing information from a table, you will be drawing information from multiple tables. 2, 3, 4, 5, 6. We won't go that far. We'll go 2 and 3, but that's what you will be doing, right? So for the next 3 weeks, please concentrate in class. Ask questions if you don't understand. Go home and repeat what I'm teaching in class, because this is tough, right? This is just new and more than what you've done in the first few weeks. Okay, so bear with me. I'll go slow. I'll give you as many examples as I can, maybe 50, maybe 60, 100. I don't know how many in these 9 hours. I'll give you an assignment and I'll allow you to do it in pairs, because putting heads together is important. Just because it's a little important. If you prefer not to work in pairs, let me know. But I've always done this in pairs because I would like people to kind of work together on joins and subqueries. But that doesn't mean, oh, you do it and I won't do it, because it's going to come in the final exam. Keep that in mind. Okay, so let's start now. Are we ready? Okay, so all the homework done. Let's now look at one, how to create tables. How to create tables, and then how to write select. First, how to create tables. Okay, so now this database is about some contacts. Information about some people, information about what jobs they would like to be in, information about what jobs are available in the market, right? So contacts, job desired, job listings, jobs available, and so on and so forth, right? So you'll see it's a combination of, you could kind of think of it as a small mini database about looking for a job. Somebody's maintaining it. Okay, so let's look at it. The first 2 lines, you've seen it many times before. The SQL mode is just saying that please ensure that all tables have strictness in terms of them, and the one that we use it for is that the null is operative. The updates, I don't think we will need it here unless I'm doing an update, which I don't think I am. So I think we can remove line number 11. But line number 10 is new to you. I have introduced you to it before. I've said that every MySQL database has a few, not only 2 or 3, I think 10, if I'm not mistaken, database engines that are used. And the default in at least in my VAMP was, in my version of VAMP was not InnoDB, it was MyISAM. But I think the other persons who were using MAMP already had that InnoDB. So I don't know what will be on the server. I have no clue. So what I've done is I've said the default storage engine is InnoDB. It is the most commonly and used engine in MySQL. And for me, it is important to use it because I'm going to now use foreign keys. And if I don't do that, I cannot implement foreign keys, right? The rule is not implemented. And I'll tell you what do I mean by rule. So please see, ensure. So again, as I said, we set our own environment because I have no clue what the environment of the server will be. So I didn't even bother, though I know that on my laptop, WAMP is running my ISAM. But all you have to do is set the default storage engine to InnoDB anytime you're using foreign keys, which we will be starting this example. So please add this to your code, always now onwards till the end of the semester. The rest lines, drop the database if it exists, create it, use it are common. And now we will start looking at tables, right? So I don't only have a table, I have, I think, 4 tables in this database. Let's look at the first one. Not so tough to look at all. The table is called My Contacts. Every person has a contact ID. It is an int, unsigned, auto increment, and is the primary key of the table. Every contact has a last name, a first name, a phone number, an email, a gender, a birthday, and a zip. Now you say zip. What is zip doing in a contact ID? Where does the guy live? Right? So zips are saved because zips are unique instead of saving the whole address. And for me, zip is important. I'm in Barrie. I'm only looking for jobs in Barrie. I don't want to go outside Barrie for whatever reason. So then you can match zip of this person with the zip of the job listings. Oh, here is a job in Barrie. So there's what the zip is doing. Okay. Now about birthday, sometimes some jobs will say, oh, I need a person who is between the ages of 30 and 40. So there is where the birthday will help. So I have picked this example up somewhere from the web. I use it every semester I teach because it's easy to understand. It has a few fields, but it's not so tough to understand it. Everything makes sense. Okay. And again, gender, for some reasons, a male is required or a female is required. So here is a simple table, nothing big in it. Is this table in the first normal form? Yes. It has a primary key. Yes. Every field is atomic in nature. Yes. Do you see any repeating groups in repeating data in any of the fields? No. We are okay. Now let's see if it is in the second normal form also. So the second normal form says every non-key attribute, that means any field that is not a part of the primary key. So the only primary key is this. There is only one field in the primary key. It says all other fields must be fully dependent upon the key. Now, is last name fully dependent on contact ID? Of course. Relationship is contact. Is gender of a person? Yes. Is the email of a person? Yes. Is the birthday of a person? Yes. Is the zip of a person? Yes. So every other field, every non-key attribute is fully dependent on the primary key. So a table is said to be in the second normal form if it is in the first normal form. That has to be done. And 2, every non-key attribute, non-key attributes, any attribute that doesn't take part in the key. Every non-key field is fully dependent upon this field. It's not partially dependent. Now here there is no partial. If there is only a field, only one field is the primary key. Where comes the notion of partial dependence? Partial dependence only will come into existence if it was 2 keys, 2 fields, or 3 fields, or 4 fields in the primary key. If the primary key is a single field, the question of partial dependence doesn't even arise. So without even saying, oh, is it okay? If the primary key is a single field, it is automatically also in the second normal form. Because how can you be partly dependent upon a field? A field is a field. You know what I mean? Partly dependence only comes when you have 2 fields. It's only dependent upon a part of the field. That's where it comes. Here the primary key is only a field. So it is also in the second normal form. So this table is also in the second normal form. Let's go to the next table. Now I'm inserting some data into the table. You needn't bother because I also did a copy and a paste. And notice I didn't add, I think there was, I removed it, but anyway, I can't remember. I didn't add contact ID because contact ID is an auto increment field. I will leave it alone. I've told you, leave it alone. That's its use. You could have, if you wanted, given your own IDs to it. Maybe you didn't want to go 1, 2, 3, 4, 5, 6, 7. Maybe you wanted to go 10, 15, 2, 7, 2, whatever. You could have done it. Nobody stops you. But auto increment means I'll leave it. Now comes your second table. It says, what is the person's current job? Right? So look, the table is called job current, and look the information. Who is the contact ID? What is his title right now? So is he a manager, a system manager, a computer programmer, a database programmer? What is its title right now? What salary is he or she drawing? And when did they start? Right? When did they start? Now look at the keys. This is an int, an unsigned primary key, right? So this contact ID here is also the primary key of this table. The title should not be null, salary should not be null, and start date should not be null. If I make these fields null, then my data is incomplete, which is useless. Now a very important thing, I'm adding a foreign key to my table. What is the rule? Think about it. This contact ID must be present in my other table. Otherwise, how am I keeping information about somebody who is not even in my database, right? So how do I impose this condition? I impose this condition by saying, now this line at 67 is just giving it a name. So I'm creating a constraint now. Constraint means a rule, like the English word constraint. I've called this, I've given that constraint a name. And how have I formed the name? Look at it. I've said, I've picked up the field called contact ID from the table my contacts, and I've called it FK1 for foreign key 1. Line number 67 is just giving a name to the rule, right? You'll say, why do rules have to have names? I don't know whether you do it or not, but if you do advanced database, then you need to do programming. And in programming, if you need to work with a rule to change it or to index on it, to sort on it, whatever, then you need to know the name of the rule. So maybe for this course, it's not necessary at all because you won't be using it at all. You can even alter a constraint. So if I don't know the name of the constraint, how will I alter it, right? So you could be doing anything with somebody, and therefore that somebody is the name. And the rule usually says the name of the table from where you are drawing it. Now, there is no rule at all that this field has to be called contact ID. You could have called it anything you wanted, but this is important. You are saying that contact ID is a foreign key, and it is referencing the contact ID of the table my contacts. This is important and should make sense to you. So what are you saying? You're saying the contact ID in this table is a foreign key, and it is referencing the contact ID from the table my contacts. That's all it is doing. Has it to be called contact ID? Absolutely not. You could have called it T contact ID. Giving it the same name is not making the relation. This is making the relation. This is important. This is important. So you can't say, oh, it's called contact ID here, it's called contact ID in that table, oh, they're related. It doesn't make that relation. Human beings can make that relation. The machine cannot make that relation, right? So to tell the machine that this contact ID is a foreign key, you say it is a foreign key, and you say that it is going to refer to the contact ID field of the other table. And usually that other field will be a primary key in that table. It will usually be the case, because when you draw values from a table, you're drawing that has to be unique in the other table. So this rule is not, it's not a rule that this field has to be called contact ID. It could be called, it could have been called absolutely something else, TKP, out of the blue. But then why do we give them same names? Again, for us, for human beings, it makes sense to us. But the information that it is a foreign key and is referencing the field from the other table has to be written in black and white for the connection to be made. Now, if I was not using InnoDB, then this rule is fine. I will write it, but this rule is not implemented. Not implemented means I could have a contact ID 5, which was not available in the other table. You'll say, there, then what is it? Where? So I have to implement that rule, and the rule is implemented in the InnoDB storage engine. It's not implemented in my ISAM. So I have to use InnoDB. Keep that in mind. Foreign keys are only implemented in InnoDB storage engine, right? So this table is your first table. This table is giving you information about the current jobs of the contacts. So what is their ID? What title do they have? What salary do they draw? And when did they start? You could have put this information in that big table, in that contacts table. But that contacts table is only giving you information about the person, like only his or her details. It's not like saying which courses is the person taking. You know what I mean? Or which college does it? No, I mean, it's not kind of confusing there. So it's been kept separate, right? Okay, so that's table number 2. And then some information in the current. So whoever is 1 is a technical writer. He or she is drawing 8,000, 8Ks, and that's the hire date and so on and so forth. Now I have put 2, though, I mean, I just put them there. So you could, if you say, you could say, oh, 7 is unemployed and doesn't have a salary and null. But I said not null field. So this wouldn't go in there, right? So if a person doesn't have a job, that person is not in this table. You'll say, but I still want to keep that information. Then you'll have to change your definition. If I want to keep that information, I could say something like 7 unemployed null, 10 student null, and then these fields, I couldn't have made them null then. I would have to make them null. I couldn't have said not null. So it's up to you. I'm giving you both options, but I'm sticking with this option of saying that they are not null. And I'm only keeping information of those people who have a job. Okay, let's come to the third table. The third table is called job desired. Now here is a list of those people who say, oh, I am a programmer, but I would like to be a database administrator. So these are their desired jobs, which could be different from what you were. Like I could be working here, though it's my desired job, but I could say, oh, I would like to work with mainframes. My desired job is a mainframe programmer, though I'm a teacher here. So this third table, again, has a few fields. It has a contact ID, a title, a salary low, a salary high. What are these 2 fields? This is the lowest I will take, but this is my expectation. You know what I mean? I can't find a job. So this is the lowest I will take, but salary high, the name is not so good. It should have been said salary expected. But Lois say, I'm ready to take this much for now because I don't have any other job. And then years of experience is a tiny int, unsigned default 0. You may not have any years of experience, or you may have 5 or 10 years of experience. Again, notice there is a foreign key here. Again, line number 97 is just to give it a name. So I've called it FK2. So the first one was FK1. This is FK2. All names should be unique. And what am I saying? I'm saying that this contact ID is again a foreign key, and it is referencing its values from the my contacts table. And notice something. It is a foreign key also, and it is a primary key of its own table. So it's a primary key because it's the unique identifying nature here. You'll say, what if the same person wants more than 1 jobs? Then this cannot act as a primary key. So if contact 1 wants to be a database administrator and also wants to be a database programmer, then I have to have 2 records of that person. Then I can make that the primary key. So I've kept it simple. You'll say, but that's not very true. A person may desire more than 1 jobs. That means may have more than 1 records. Then we'll have to change. We'll have to change the primary key from contact ID to contact ID plus a title ID. And the title ID will be in a separate table. Like I'm just going simple first. This is my first example, okay? I don't want to make it too complex. So that's my job desired. So whoever is 7, I think the poor guy didn't have a job, wants to be a computer programmer. I don't know what 8 is, but wants to be a computer programmer. So this is saying I'm ready to take 8,000, but my expectation is 10K. I'm ready to take 9, but my expectation is 15K. The 10 was a student. He's ready. He wants to be a baker. So he says, I have 2 years of experience, so I'm okay. My expectation is 7, but I'm ready to take a 6. And the last table is job listings. What jobs are available in the market? This table is not related to contact ID at all. It has nothing to do with the contact ID. So notice it's not referring to anything. It is just as a job ID. It has a title, it has a salary, and it has a zip. So it is saying this job with this title is available for this salary in this zip area. So job listings is an independent table, has no relationship with contacts at all. And that's fine. I mean, a table can exist in a database that has no connection at all. So if a person wanted more than 1 jobs, I could have created a whole job new table and then said, oh, we'll make the connection. But here is a table that has no relationship. So I don't see a foreign key rule here, which is okay. So it's not a rule that if they have more than 1 tables, every table will have a foreign key. It depends upon what you're doing. So now form this picture in your head, but you can't keep it in your head. So I'll tell you a way of how to see this in a graphical, in a GUI form, right? So what I'm going to do is I'm going to show you something. If you go to databases, yes. If you go to databases, click this one and go to reverse engineer. I'm going to show you a graphical interpretation of this table that I've just created. Okay. Okay. Before I do that, come back to your here. Let's cancel this. I think I'm not even sure whether I have run it. Okay. So this is the table we are working with. Run it once. Just run it. Just execute it. There is nothing much. Table was written, and at the end, I've done a selection from all the 4 tables. And then, of course, there are some things we will learn how to do today, which are all commented, but I've done all 4 tables are listed. Run this once, run this script once. Why do I say run it? So that the tables are created. If the script runs successfully, which it should, because this is the same script that is on Blackboard, you should have 4 outputs. Contacts, the people who are in that job. Now, this table in itself is not a very helpful table. Contact ID 1 is a technical writer. Who is 1? I don't know who's 1. So you will have to come back here and you will say, oh, 1 is this guy. Oh, so this guy is, so you'll have to kind of make a relation. But then the whole purpose is you don't repeat data. You repeat the minimum amount of data. That minimum amount for here for me is the contact ID. This is 3. These are the job desired. So 4 wants to be a sales manager, 7 wants to be a programmer, and so on and so forth. I don't know who 4, 7, 8, 9 are, but I can always go back here and say, oh, 4. So Joe wants to be this. Oh, 7. Oh, Renee wants to be this, and so on, right? And the last table has no connection anywhere, but is a job listing table. These are all jobs out there in the market. Okay. Now, so 4 tables are there. There are relationships between the table, and I want to keep it in my head. It's kind of a little difficult, but there is an easy way to keep it in your head. If you go now to database, once you've executed it, and you go reverse engineer, and just now follow. So all it is saying is, what is your connection name? So I'm following this connection. I mean, it won't change it unless I'm in the same connection, and I go next. It says, okay, I'm connecting to the database. I'm retrieving the schema list from this. And I'm checking the server configuration. Everything is okay. Click, click, click. Yes, everything is fine. Go to next. It says, of which of these databases, now you won't have such a long list, so don't worry. It says, of which of these databases do you want to draw an ERD? I'm trying to draw an ERD, entity relationship diagram. Entity, each of this is an entity. Contact, each of these tables is an entity. Relationship, what is the relationship between these tables? How are they related? Diagram, right? So now I have a long list. Whatever you have really doesn't matter. So pick up the name of the database, which is that one. And which was it now? What did we call it? So look it up. It should be something DB jobs. So what was the name of the table? Oh, can't even see now. DB. Okay, I see a DB. Jobs looks like the ones, right? I think that was the DB name. So click that. Just check it. I have so many, so I don't even know, but I'm almost positive it was called DB jobs. Anything else that looks familiar with DB jobs? Students, toys, try. No, I think that looks okay to me, right? And say next. So it's now retrieving the objects from the schema. Schema means your database in the rough language. It is taking the result and it says, I'm done. I've done your job. You'll say, where is the diagram? Do a next. And it says, I imported 4 tables. Remember, we had 4 tables: contacts, job desired, jobs listing, and current job. Okay, execute it. And you will notice that there. So let's kind of give me a minute. You also pull them where you can see them. And then I'll explain in very layman language, I'll explain what this diagram is doing. Okay. 1, this table was independent, so it is not even linked to any of the tables, right? So there it is. There's the job listings. Now let's look at those 2 lines that you're seeing. 1 to infinity and 1 to infinity. What it is saying is, now you can do a few things. Now try to read it. Notice how you have a key with that contact ID yellow in color there. So it's telling you that contact ID is a primary key. Notice that the color there is red instead of yellow because it is a primary key also and it is a foreign key also. So the color is orange. Right? Do you see the 1 to infinity or do you have something else on your? No relation. Okay. So what did you miss? I know sometimes that line doesn't appear and you missed something. Oh God, some students do complain to me. Oh God, I forget now because I've always had it. Give me 1 second because I know some students have it. They don't see the lines. Oh God, what do they miss? They're missing something and then it comes back. Did you execute it before doing it for sure? Did you run your script before you made the diagram? because that's the only reason I can remember when lines don't show up. There are different kind of lines, but some line must appear. If you kind of click on it and do a right click, you can change it. You can edit a relationship, you can delete it and so on. But I mean, I don't have to do that. But you should be running it. Anybody else having that problem that the lines are not showing up?
The lines are showing up. We just can't see the relationship.
Oh, you can't see the relation. Oh, that's okay. That I can tell you what's the difference. Give me 1 minute. Where is that? Give me 1 minute. I've just done a different kind of I'll tell you what it is. The lines can be changed. Oh God, model. That's me. That I must have done it. That's not a big thing. Model. Relationship notation, maybe. It's been a while since I changed mine, so. Oh, there it is. Okay. Go to model, relationship notation, and mine connect to columns is connected. Yours could be maybe classic or crow's foot or whatever. Change that. So the crow's foot looks like this. It kind of is the same thing, but you have to interpret it. So the crow's foot looks like this. See, notice how it is one there and many here. So that's a one to many. Right? So if I look at the other way, it was saying one to infinity. Infinity means many. So this is called the crow's feet because it's like a crow's foot, right? So this notation, and if you read it, it has a one on this side. There are two ones, but the other one is just a line. So it's one on this side and there are many on this side. So what it is trying to say, that's the interpretation it did. It said, you said that this is a foreign key in that table, so that contact can have many listings here. Now our table doesn't, which is a different thing, but that's the relationship. So that's a primary key there. It can only occur once there. But the same contact may have different job desired here, is what I've said. I haven't said anything else, though it should be smart enough to say, oh, her primary key is different. But that's the interpretation it has made. So there is a one-to-many relationship between table my contacts and table job current. And there is a one-to-many relationship between table my contacts and table job desired. Also, please notice that there is a key symbol of yellow color in there, which is a primary key. There is a yellow symbol here, which is a primary key. This is also a key symbol, but it is red in color. The red means it is a primary key and it is also a foreign key, right? And when I use my relationship, the other advantage of using the relationship I had is it will join the field of that table that is related to this table. Right now, it's not joining it. It's not telling you, oh, the contact ID there and the contact ID here are related. And again, I repeat, having the same names doesn't mean there is a relationship. Doesn't mean that. The relationship has to be imposed by the programmer in the code, which I have done by doing that for you. So the one that I use, I like it more because of this particular reason. If I say I want to use the connect to columns, then notice how it is connecting the column contact ID there to the contact ID. So I know, oh, this is a foreign key of that. So that's why I like to use this notation. So I would recommend you use it, but it's entirely up to you. So this kind, now, if I have this diagram, so now whenever you do assignments, and in the exam, I'll give you the diagram. So that now you can, anytime if I say, oh, what is the job that Anju desires? So I'll pick up Anju from there. I find the contact ID of Anju from there. I'll come to this table, look for Anju's contact ID and say, oh, she desires to be a mainframe programmer. So this way, when you see a diagram, it is easy to relate what's connected to what field and answer queries. So I would highly recommend in your assignments and also for your exam, I'll make it for you or you can make it in a minute. I'll make it and maybe bring printed copies. When you have a diagram in front of you, then it's easy to write answers. So now actually the right way of doing it is first drawing the diagram and then writing the script. Because you don't write first and design afterwards. You design first and then write code. Therefore, if you notice, I had said reverse engineer. I was going the other way. Because sometimes it may happen that you join a job, which will happen, or the database is already created, tables are already created. Now you are doing something on it. You won't start creating a new database, new tables. Something is already available, so you have to use it. Of course, you can alter it a little. So that's where you will use reverse engineering. So somebody's already done a job, you are just going forward with it. But of course, usually you will, not usually. When a database is created, it is first designed and then created. Okay? So this will come very handy. So this is available in MySQL, in your IDE, in the workbench. And all you do, as you now know, is go to database, choose reverse engineer. So notice there is a forward engineer also. You can actually draw the diagram yourself. Here are all the symbols. You can draw diagrams, and that's what is done. You draw diagrams yourself first, and then you do it. Now, if you kind of click on any of these, I'll tell you what these indexes are, just so that you know. You won't do it in your first introductory course. What it is saying is that this table is sorted on the primary key. That's another advantage of a primary key. The table is kept in a sorted order in the database. Why? Keep in mind, even we know it, human beings know it. It's easy to search for something in a sorted table rather than in an unsorted table. Like a phone book. If you didn't have a directory, like if it was not sorted, think of how would you look for a name. So these indexes are telling you that each of these tables are sorted on the primary key, which is the default. I didn't tell it to sort it, it did. Which kind of makes you think, oh, can I sort it in another field? Can I create an index on another field? Definitely you can. You can create as many indexes as you like on a table as long as you need them, not for the fun of it. So if I had created an index on, say, zip on that table, which is not in your course, but it's a create index command, that would have listed in the indexes for your information. So all this is in the second course of our programmer students. I'm not sure if IWDD does a second course in database. I can always find out from Scott. That's where these things will be done in more detail. The aim of this course is that you can do CRUD. You can create, you can retrieve, you can update, and you can delete. You should be able to do these 4 operations on tables in a database. And that's what the course is. So I can't diverge a lot because I have quite much to do, right? But anytime you want to come and talk about it outside class, you can. Okay, so there it is for you. I'll keep it open, or you can always save it as a PDF, or I think copy paste, I can't remember, and then keep it as a hard printed copy, and it's very handy. I usually get one, I forgot one. But anyway, hopefully I'll be okay. So now let's come back to this table. Okay, so now before we go forward and start doing our 1, 2, 3, 4, 5 here and the other table, any questions that you would like to ask me of what I've done till date? So there are a few concepts right here. A database consisting of more than 1 tables. These tables are related to each other. Every table will and should have a primary key. Every field must be atomic in nature in each of this table. And the relationship is exercised or implemented, not exercised, is implemented using foreign keys. We have not yet seen a composite primary key here, but we will in due course, right? So this is your base. And the definitions of the first normal form and second normal form, I'll put it somewhere in this script so that you can handle it and remember it. Okay? We'll take a break here. Take a 20-minute break, and then we'll come back and start doing these queries. Okay? So all this, of course, is already on Blackboard. With definitions, I'll put them up. I don't know why I didn't. I should have. Anyway, I will. So it's almost 12, kind of 12:15. We'll go with 12:15, and I'll see you back at 12:35.
I'm good. Yeah, I didn't match with it, but I was talking. Dang it.
Yeah. Like, once again, do more than we do. Well, I still have a boyfriend, and so I'll be using Tinder to like.
That's cool. I'll be.
Would be
It's like this cute girl was there. This cute girl was like really doing business, but said you're in college. I'm like, well, they started in college, but they're so close. And then like, she's like at my Insta. And then one of my friends is Zach. Oh, Zach. Is the same person? Like, no. We're just
buttons. Well, yeah.
What happened? Yeah, before. What's your job? I did look, this is mine right here. Yeah, I know about this.
What?
I'm actually sure.
Yeah, right?
So it's supposed to be like 8 minutes to sleep.
Apparently it's not a big deal.
No.
Like, keep it over.
No, right. What I'm doing is I don't like where I put one go to sleep and shut down. Yeah,
Some people don't even, but those are mostly best times.
Yeah. That has to be, like, I don't leave it running all the time. That's not.
I don't even sleep. I just turn it up. Because sometimes I put it to sleep mode, I don't even rush. I open it again and the battery is like,
No, it doesn't actually turn it on.
I think so.
Yeah, it's not actually. That doesn't have to go on. But it's never unplugged. I thought it was just on call.
No, it's here.
Well, what is this?
The one where you just add the call it to one.
No, he didn't mention it first. He said he was gonna add on top of bridge.
This was like this. This is
But I didn't check it.
Oh, it's not. Are you trying to get around to this one?
Where's it supposed to say? You guys better sneak it in, you didn't even hear this time.
Grab my bus.
I thought you might have been like on time or something. So is it
Just a reminder.
What did you ask? Try to email it. Guys, what's
what's his name, what class, I have no idea. You'd have to email him.
the penny doesn't.
He definitely did report. But I don't know if he's good posting.
Okay, this guy's playing this really.
Show you how to Eurostep.
These 2 7s. I was supposed to say David Harbour is like the coolest person. David Harbour. He's the police chief from Shanghai.
Oh, yeah.
Not only did he have the best Super Bowl commercials, but he always does like social media things where it's like one girl was like, how many retweets me to come post on the Trump picture? And he was like, look at that one, like that, but I get to hold a trombone in the picture. She got it and he actually came and did it. He does a lot of those types of things.
Exactly. I got so excited. I'm like, holy shit.
No, I mean, like I said,
I'll show you.
That chick would be so damn like stressful to be with.
I wouldn't want to be with it. I would just straight up be like,
That's really don't bring home a mom and dad.
look at the door I'm doing. I don't bring this home to mom and dad, especially when I get. This is what she said. She's like, wow, I'm like,
I've been like, I don't want you at church. What's wrong with you?
yeah, you need Jesus.
Jesus is kind of tricky about it.
She's like, I need to go to control.
Really? That's nice though. I really actually pretty good.
did you design it?
No, but
Oh, I
they
wanna
said
see
they
that.
might.
Holy shit, did you make that?
Yeah.
Yeah, see, that's what I'm saying. That's really good.
Yeah, they really like the lift one. They're like, oh man, this is more appropriate to the lifties. So like she sent it to the lifties.
Where's the other one?
Oh, it's like, I think you're right. If you lift it,
I like it.
You just get all the bros and stuff.
You're so you live with. I'm sure you do.
Yeah, but you're not gonna get, I just have to put like hashtags Space No Valley. I think that's first, watching like a long.
Yeah, along with everything.
Oh,
Yeah.
there's a t-shirt, that's not-
Yeah, for their sign t-shirt.
Well done. What'd you make of it?
Just started.
You get paid or not?
Yeah.
Good. Good. Well done. Yes, very nice, yes.
Are you making it right? Really good carbs.
No, man, I just.
Good show.
Fuck that, man, I just like to stretch.
Oh, no, there they are.
Like everybody can see it perfectly.
Yeah.
You get someone. It's funny, he came in, when he came in late to Thursday's class, he sat down next to me and like, I moved a couple times, like,
Yeah.
and he's gonna keep going. And then,
Then at one point we were all like,
Yeah. Alright. Talking says, no, but we're about to start.
I see how it is.
Same.
Good. We thought you weren't getting it. Oh, come on. I got it.
thank you. Let's get more water. I got a little on your phone, sorry.
They make waterproof cell phones. Why don't they make waterproof?
Because I go to school and I was like,
I don't know.
okay, sorry, coffee per time.
I think we're good, it's mostly on the surface.
I've done a lot of shower. Okay, yeah, so good.
That's okay, all the way upside down.
Yeah, extra like
Are you kidding me?
Yeah, I was I didn't do the towel. Honestly, the towels was tough. It did, like after laundry.
I didn't have time.
You know how it goes, you do laundry, and then you don't fold it, you just throw it on the sofa.
No, that's not
The chair.
that's not our responsibility.
And then slowly you pick through them. And you never fold them. You just look at them.
You hope that something.
And then one day somebody tells you to come over and like a cancer or something, and you're like, shit, now I gotta fold it.
I just put out like small.
You didn't shut down.
No, it's fine. It was mostly on the surface. What?
Yo, if you think so, if you're inside, it might be better to start it outward then.
Yeah, I don't think it did, to be honest. It's a good point. Yeah, that is a good point.
I'm saying like if I put
If it's still running,
yeah, see like if I put it here, if I want to go over the top of it. Yeah.
That's what it happens.
Oh, if you want to feel really bad about yourself, we'll do it.
I do.
I want to feel bad about myself.
just I mean, I got I thought he was gonna take my song back. I was like, oh,
Thank you.
shit, no problem. Oh, I thought CSS was gonna be simple. Okay, that's I thought the CSS was gonna be simple. Hey, shut up. This is not fair.
Marion ran away from us, scared with Luther.
Wait, you use a sweat editor?
Oh,
Cheat.
That's pretty nice. Yeah, man, good job. Yeah. Yeah.
Oh, you know, so I thought while you were clicking out the buttons.
Okay, guys, let's start.
you're reading a lot, like command you say speed. Yeah. I hope he's not.
Okay, so let's start answering your queries now. There are a few things. So I'll talk about a few verbs or statements that are already available. They can be called statements. Actually, they are verbs. Union, intersection, minus, and so on, and let you know what MySQL doesn't have. So I'll do a little bit of standard SQL, and then we'll kind of say, oh, this can be done in MySQL. Okay, so let's start looking at the queries and then I'll answer them. And then, as I said, we'll go from there. Okay, so the first one says, so that there are two verbs. One is called union and one is called union all. It says to get all possible job titles from all the three tables. So I'll refresh your memories. These are the three job tables. Oops, these are the three job tables I'm talking about. So here they call it EER diagram. It's actually EDR, entity relationship diagram is what we call it. I think maybe E is for extended or something, but ER diagram is what it's called, ERD for short. Okay. So my aim is, the question is to get the job, all job titles from these three tables. That's what has to be done. That's question number one, right? So the question number one says, so I'll kind of keep coming back to this. You can always save this. This diagram can always be saved, and otherwise it takes 1 minute to make. So you can save it as the script. Okay, so let's do it now. So now it's easy because there is something that's already available to do it. So if I just want to pick up the same field, the job title from all the three tables, that's all I do. But you have to keep in mind, these have to be, the field name has to be same. Okay, so let's do it. So it's select. I'm just calling the new field title. Oh, sorry, I'm just picking up each field from the table. The title fields from the table. Okay, so from the three tables are, if you don't remember them, I have their names here. That's table number one. I want to pick up the title from this table. I want to union it with. The difference between union and union all, if you notice, it says removes duplicates and keeps duplicates. That's the only difference. So whatever is the requirement, union. So you don't have to kind of do anything on your own, no programming, it's all there. So please notice the field that I'm selecting has to be, I mean, it will, you won't say union, color from here, name from here, and age from there. It doesn't make sense. When you do a union or you collect something, you collect the same field from all the tables. Otherwise, union doesn't make sense at all. So select the title, and the other table, the second table is job desired, it is called. That's what union does. Just we'll do a select. We'll see it. Okay, give me a minute. Let me complete it. Union. Oops. And the third one is job current, job desired, and job listings. Listings it is called. If you want, you can. I mean, nothing stops you. It's just a select statement. You can always order by, just because it's always easy to see ordering by something. So the only field I have is title. Okay, let's try it. So union only makes sense. You try to combine something if it is the same field. Otherwise, it makes no sense. So all I'm doing in this one is just to show you what union is. I want you to pick up the title field from all the three tables. That's all I'm doing. What jobs are desired, what are available, what are in the listings. So if you take this and run it, because we've already run the script once, see, all it does is, and that's what union does. Now, if there are any duplicates, which I think there will be, then they'll come. If you're using union, will remove it, and union all will keep it. So if you put a union all here, you will see duplicates. Union has no duplicates. That's what union does, right? Please keep in mind, select is only selecting it and then showing it on the screen. That's all it does. That's what select does, just shows it on the screen. Today, I'm just going to kind of show you how you can create a new table and do it. So I can keep this here. I'll keep this here. You can actually keep this new data in a table. This is just displaying select. We all know select doesn't save its results anywhere. You will say, oh, it didn't save it. If I want to retrieve that results, shall I run this code from 150 to 158 every time? Yes, you do. It's just a statement, right? But if the nature is you want to save it somewhere, you do your create table command. We know how to create a table. We know the create table command, except that it will be a little different. So I'm going to say create the table. What would you like to call it? We'll call it table, I don't know, all titles, all job titles, whatever you would like to call it. So name your table like we do, create table, the name of the table. Now, what I want to do is I want to pick up the title field from here, the title field from here, and the title field from here. and their names are the same, and create a table with this structure. It will only have a field and it will have all those values. So what you see here is what I'm trying to create, right? And I don't have to kind of do anything but this. I'll say as, because I already know that the result of the previous query is a table, though it only looks like, I mean, I know it's not a physical table, but there it is. So what have I done? I've added line number 161, which is now creating a physical table in the database. Till now, all select statements were just showing your results on the screen. Now you know how to get that result in a table if you want. Just so that you know it can be done. You'll say, how do I know? Maybe that's not what it is. Here it is. Do you remember that command, show tables? Let me see what tables does it show me. I had 4 of my own, remember, contacts and 3 more, and now this is the 5th one. Let's see if I see 5 tables in my database. That will show my tables in the database. And just so that you can see that, display the table structure. Tell you that, to prove to you that physically a table has been created. And I mean, you look at it, there it is, it has been created. I mean, there's a command there, so how it would be created? So remember how to create the table structure? Describe, and give the name of the table there. And here I'm going to show all tables in the database. To prove to you that this is a physical database in the table now. Oh God. Run these 2 commands. We've already run this, right? So we've already run the first one to show you it works. So create the table and then do the describe it and show all the tables. So this is the description of the table. By default, it has one field called title, varchar 30, because that was the size of all the 3 fields. Null, yes. Okay, so it has not kept the property. We'll have to alter that property anyway. And then here are the tables in my database. Notice a new one has been added. Where is it? Here it is. That's the new table that got added. Job titles. Now you know how to, but of course, I mean, it was simple here because all the tables had the same field title. Of course, it's the same field, same size, and therefore it created a field. It's not that easy every time. It depends on what you're picking up and so on, but you can do it. You can create a table on the go. Okay, so that's the union, but you have to remember a few things in union. When you're doing a union, you're trying to unite the same field in all the tables. That same field has to have the same size and name, otherwise it doesn't make sense. Okay, now the only thing, the null didn't come up. It said null yes, and that's the only thing I'm a little kind of, oh, here it was not null, so that's why I didn't pick it up. Okay, I think if I'm, oh, they are not null. Oops, okay, my mistake. I thought that field was not null. It is allowed to be null. Okay, that's okay then, right? So there it is. That's union. Just to let you know, it exists in MySQL, it works. Of course it works, otherwise it would have given us an error. Now let's look at the second question. So somebody wants to know, what are the titles that are common in job listings and job desired? So I want to find out, oh, these are the jobs that are available and people also desire them. Common query, right? It's a common question that could be asked. So what are the jobs that are available and people want those jobs? So that I can know these jobs are, like, nobody even wants these jobs that are listed. So now I want to know what's common between the jobs in the desired and jobs in the listing. Now, for your information, there is an intersect or intersect all, and you would just write it as if you were writing the union one, and I'll write it for you, but it doesn't work in MySQL. It is not supported in SQL at all. So I'll have to think of my own way of doing it. But if it would have worked, this is how it will look. It will tell you it's an error. We'll select the title as if you were just doing it. You will select the title from which table? TBL job listings. I'll just pick it up from here. And I'll use the intersect verb, which doesn't exist in. It would be so easy if it existed, right? We wouldn't have to do it ourselves. Unfortunately, it does now. and the other table was desired. Now, if this worked, we would be done and finished, but unfortunately it doesn't. There is no intersect verb in MySQL. So now you think about how logically will you do it? How will you know that these jobs are in the listings and the job desired? What are common? So you have to look at both the tables. You have to pick up a title from one of the table. You can take any of the first table. There's no first and second. There is no parent and relationship, but pick up the title from one of the tables, search it in the second. If it exists, spit it out. Do the same thing with the second record, the third record, the fourth record, and so on and so forth. That's the logic. How else will you do it? But this is not available in MySQL, but it is a feature of standard SQL. So I'll kind of put it here so that you know it, but we won't be able to test it. So 2B says, now we'll do it. So I put it in 2B, which desired jobs are available in job listings. That's my question, right? Now, here is your time to be introduced you to joins. So I want to join the two tables. There are a few syntax ways in which you can do things, right? You can use the word inner join, you can use a comma, you can use natural join. So I'll introduce you to all of them together. So when you join two tables, if it was just a join, table 1 with table 2, this is what happens. Every record in the first table says hello to all in the second table. So it's like if I say here, introduce yourself to each other, each one of you will kind of go to every other person and say, hello, my name is Anju. That's a join. So imagine like, and again, you'll come back. So if I've already said hello to Sahin and Malika, they'll come back again when it's their turn, they'll come back to me and say, hello, Malika, though I've already met them. But that's a join. Join says every record of one table says hello to all of the other tables. Let me show it to you so that you can see it. And then we will write the answer. So let's select, right? I'll just do a star because I'm not particular about what I'm doing. From. I'm going to write it in its easiest way, okay? So that you can see the results. And then we'll say, oh, what is a join? So I'll write it here. And I'm going to use the word inner join, though there is an easy way of replacing that word with, but my aim is that you go the right way to, and I'll just do an inner join. Here, I'm showing you how two tables are joined. That's all I'm showing you here. And see what will happen. Go back. There are how many in job listings? Let's look at how many records in job listings. Job listings as, you know what, I'll do this. Oops. Instead of counting them. Okay, so here are my tables. That's job desired. 1, 2, 3, 4, 5 records. It is an easy way. You should be able to kind of maybe also say how many. I mean, you don't have to count them. There should be some way of saying 5 records. It will say somewhere here, but here also it should say. I'll look it up. It should be somewhere here. Result grid is all it is saying. If it would number for me. Okay, so 1, 2, 3, 4, 5 records in here. And listings has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many records are you expecting in when everybody says hello to everybody? 5 in the first one, 14 in the other one. What do you think will be the total number of hellos said? Every record says hello to every other record. 14 into 5. Right? Kind of think about yourself. There are 5 here, there are 5 here. So these 5 say to all these 5. So it becomes 5 into 5, 25. So what's 14 into 5? 5 for the 20, carry over to 4. 14 into 5. My 14 table is not good, but I can do math in my head for sure. 5 for the 20, carry over to 70. So the result should be 70, right? Now let's look at it. And we see the answer. Do you see the last row? The last select that I did? 70 rows. That's what an inner join is. Everybody says hello to everybody. Right? That's what an inner join is. It's called an inner join. Okay? Now we will go further. Everybody understood what inner join is? Now there is a restriction here. In the job desired table and in the job listings table, do you want every job to say hello to every job? No. When do you want to say hello? When their titles are the same. That will tell you who matches who. Make sense? Right? So if I say what are the job desired and they are also in the listings, who says hello to whom? If the titles match. So if I put all my computer students together in a class and I say all IWDD students will say hello to all IWDD students. So I'm kind of saying, oh, your program should be same as your program. So now think of what should I do? I can do the condition. So I say join the two tables, but only join where the titles are the same. So then I know this is in job desired also, and this is in job listing also. Does it make sense? So now let's try to do that. So till now, and this is the answer. Here are your 70 records. Everybody of the first table, so job ID, title, salary, zip is coming from the first table, right? And then this is your job listing. And the rest of the fields, title, salary low, salary high, years ago are coming, years of experience are coming from job desired table. So every record says hello to every other table, every other record, and their records are joined together. That's what an inner join is, for your information. Now I have to lay a restriction. So logically, step by step. What is the restriction do you want to lay? You want to say, oh, I don't want to select everybody. I only want to select those records where the title in the first one is equal to title in the second one. Now both fields are called title. So if I say title is equal to title, there will be utter confusion. Whose title am I talking about? Now they could be called differently. I could have just called them title 1, title 2, and then there would be no confusion. But as I said, programmers prefer to call fields the same name because they don't want to think of many names. One. And why should I say title 1, title 2? Title means title. So what can I do? All I have to do is qualify it. So I can put the name of the first table in front of this title and put a dot. Qualify it. Take the table of the second name, take the name of the second table and put it in front of the second table. Oops. And put it in front of the second title and qualified. You've seen this dot before. Remember, database name dot table name. There it is. Now I have laid a condition. Now only those records will come up on the screen where the titles are same. So the first one you saw, which was an inner join, is actually also called a Cartesian join. In mathematics, it is called Cartesian joins. It's also called Cartesian join. It's named Cartesian join. Everybody says hello to everybody. Right? So if there are 20 students in my class and every 20 says hello to every 20, 20 into 20, we'll have 400 hellos at the end of the hello system. Think of it. Now, on the other hand, if two of us have already said hello, then we've said hello. We are friends already. Right? And again, if I say, okay, everybody says hello, but only people who are wearing a hat say hello to each other, then we'll only have some, I see Brandon, I see Joel, I see Andre, only those guys will say hello. So I've kind of restricted it. So definitely there is, oh, the hats guys are saying hello to each other. Okay. Now let's see what we have as the answer. So pick up this now and see if your answer, you've got your answer. You've done an intersection. And see. Yep. Now I've made an intersection. So these are those people, not those people. These are the jobs that are in the market and are also desired by somebody. Now, who that somebody is, we don't know. 10, 7, and 8. And notice how 13 is coming twice because 13 said hello to 7 and 13 also said hello to 8 because their computer programmers were matching. All I said was they should match. So this 13 is a job, it's a listing, it's a job in the computer programmer is a listing. Two people want it, or vice versa, whatever it is. Right? From here, I know it's in the job listing because those fields are coming in the beginning. Why are they coming in the beginning? Because I wrote this table first. I could have just swapped them. The desired fields will come first and then will come the listing. Now you say, oh, I don't want to see all of them. I'm only interested in the title. Remove the star and put what? Just put the title, only title will come up on the screen. Now there is a little bit of ambiguity. Whose title are you talking about? Anybody's will do because they're both equal. Anything, any of the tables will do. Why? Because their titles are equal. Pick up any of them. If you don't do this and you only say title, it will give you an error. Try it. It looks okay. There's no red squiggly or anything, but see. Column title in field is ambiguous. Ambiguous means, oh, who does it belong to? Whose title are you asking for? Where do I pick up this field from? I see two titles. I see a title in the first table. I see a title in the second table. You say, but I've told you they're equal, but it's not human. It's a dumb machine. It has to be exactly told what needs to be done. So we will have to exactly tell it. Wrong place. Control Z is what I wanted to do, but anyway. Now it will work. So I went step by step with you. I first showed you what an inner join was. We all said, oh, we only want those records to say hello to each other in which the title was same. So we put a condition. And then instead of seeing all the fields, I said, I only am interested in the title field. Right? So let's try that now. It really doesn't matter. It will only pick up the title. Baker, computer programmer comes twice because it had two friends. Right? It had two friends. It said, oh, computer programmer is in the listing. Anju also desires it. And Matt also desires it. So they came twice. There were two matches. You will say, oh, I don't want to see them twice. My aim is just to see what's available and if you want to see this result, good. That's fine. So this will tell you there is one baker in the market and one desires it. The second one is saying, no, we can't make the second one. Maybe there are two listings and one desires it, or there is one listing and two desire it. We don't know. Like we can't make unless we show all the records, we can make a distinction. But if you only want to see it once, remember this, we did it last week, put distinct in front of it. It will only come once. There's nothing to see it twice, but if you only want to see it once. Go ahead.
What if you wanted to, so it'd be like, so we could be able to like select
the fields.
ID, like
just
ID, and you wanted to have.
Just list them.
Okay.
Just list them. So if you wanted to show the contact ID or job ID, whatever it was called in the first, just list the fields you want. Right? So list the fields you want from the first table, list the fields you want from the second table, and please qualify them if there is ambiguity. If there is no ambiguity, then we don't have to qualify them. Okay. Salary is only in one of the tables. Just say salary. It will automatically pick it up from the right table. You can show any number of fields from the two tables. Star will show you all fields, list like normal select statement, and the fields that you want will show it from whatever table you say. If there is no ambiguity, you don't have to qualify it. If there is ambiguity, definitely you have to qualify. So if I wanted to show salary or whatever, all I'll do is I'll just put a comma here, for example. I'll say salary. I know salary was one of the fields in one of the tables, right? There was something else also, job desired. I don't know what else was common. Oh, listings, there was a zip in the listings table. So you can just show whatever fields you're interested in.
So you'd be able to select from both. So
Exactly.
like, how would you do the second one though? So you select this.
See, look at something. When you did a star, what happened? Look at the answer. When you did a star, all the 4 fields from the first table and all the 5 fields from the second table appeared.
Yeah.
Right? Now choose whatever you want.
So you would be able to select the contact ID from the second table.
Yes.
And you'd be able to select the title from the
Yes.
table.
You can select any of these fields now.
And how would you
do it? Okay, here. So you want to select the job ID from the first table? Maybe the contact ID from the second table? Maybe the title, but now with title there is an ambiguity. Title belongs to both tables. So you'll have to say which title do I want to pick up, though it doesn't matter which one because they are equal. Okay. And then of course the star will not do. Yeah, so job ID is coming from listings, contact ID is coming from desired. See, these here, zip is the breaking part. The first 4 are job listings, the last 5 are job desired. Pick up any field you want. I only placed a distinct because there was duplicates. If you don't want to, don't do it. Pick up any fields now. So star gives you all the fields, everybody who says hello here to everybody who says hello here. But the condition is only those people say hello whose titles are the same. So try without a where condition, try with a where condition. When you don't have a where, everybody says hello to everybody. We had 5 records in the first, 14 in the second, 14 into 5, 70 was our result. Now I've put a condition. Now when the condition says, okay, now just don't do it. Do what I tell you to do it. Make sense? Any fields can be picked up. It's entirely up to you. My question was, which desired jobs are available in job listing? My question was only about titles. Therefore, I only was showing the title. The question, if it says, oh, the job ID, whatever you like, entirely, you can select fields, you can put a star, you can do whatever you like. I just chose to do this, but you can add whatever you like. So you can do a star if you like. And, oh, sorry, you can do a star and all fields will appear. You can give a list of fields if you like, in any order. It's just for display purposes, remember. You can give a star for all fields, if you like, or list of fields. Pick up from any table. But if the field name is the same, then you have to definitely qualify. Make sense?
Could you do like select all from job listings, but not job desired?
Then you'll have to list them. You can't say star from here, comma, only this from here. Star, now you're talking about a table. So when you're doing a select statement, the tables have been joined first. So when you do a star, it picks up everything. You can't say, I mean, it doesn't know star of this table and not of this table. So you will have to list them. The select star will list everything from both tables. Otherwise, you will have to make a selection of whatever you want. Okay. My question was, I was only interested in titles. So I said title. That's how I did the intersect. Make sense? Right? So you've seen your first example of inner join. Now, just for your information, because I said there are a few formats, I'm going to give that formats for you. This is format number 2. You can put on here if you like, instead of where. So here are format number 2. On instead of a where. This is format number 2. There is a third format for your information. The third format says using. Let me show you that too. At the end of the day, it depends on you, what you want to do. Everybody has their own. That's format number 3. The common field is put inside the using. But remember, using can only be done if the field names are same. This is important. Otherwise, I just am saying using which field. They have to be the same name. So if the fields have the same name. Again, keep in mind, these two fields could have had different names altogether. There was no relation, there is no relationship by virtue of being named the same. The relationship comes from what you are making it. So you can use the using word here instead of where and on. It's simple. See, it's cute. Just saying using. But you can only do this if the fields have the same name, which there is another way of doing it. There are a few ways. Instead of the word inner join, you can use natural join. Natural join will automatically, oops. Okay, so this is coming from the comments. Okay, natural join will automatically join on same named fields. Automatically, you don't even have to tell the field. So there is again a restriction, natural join, if the fields have the same name. You don't even have to say using. You don't even have to say using. Okay, so here are 4 of, okay, so you use the word inner join and say where, like you've done till now. You can use the word inner join and use on instead of where. You can use the word inner join and say using, but the restriction is the field names have to be same. Okay? So title is called title in both fields. Instead of the word inner join, you can say natural join, like English, naturally join. Join how? On common fields. So if the fields have the same name, they are automatically joined on equality. Now, if you wanted to join them on something else, not equality, oh, I want to join if one is bigger than the other, one is smaller than the other, one is not equal to the other, then natural join cannot be done. Natural join means joining on equality. You can join on anything. I can say everybody who is not wearing a hat says hello to somebody who is wearing a hat. Right? You know what I mean? So the joining could be on anything. But if the joining is on equality, then you can use the word natural join. And the field has to be named the same. It says, oh, you're called title, you're called title, I'll join you on equality. Then you don't even have to give a condition. Natural join automatically means joining on equality on the same named field. Easiest of all. You don't even have to give a condition. But it's up to you. Everybody is different. And lastly, one more. You can use, which I think you'll get into the habit of. Last, you remove the word inner, join, and put a comma. But you can only use where. You can't use on here. So don't write the word inner join, put a comma. And this is a inner join, but you have to give a condition. And you can only use where in the condition. You cannot use the word or. Use the comma and where. This is the last way of doing it. So 5 ways of doing the same thing. Whatever works for you, I'm fine for it. So comma with where, inner join with where, inner join with on, inner join with using, and natural join. We did 6 ways of answering the same query. Whatever makes sense to you. But in natural join, you have to remember that you're only equality. It's only for equality. Natural join only works for equality of the same named fields. Using only works for the same named field. Right? So I've said that using title is the same thing. So using with inner join is the same as natural join. In all these cases, hopefully, I should have the same answer. Right? Let's try. How many did we have? 3 of them. Did we do a distinct everywhere? So 2 records in all the answers, right? So the last, if things are going right, the last 7 answers or 6 answers should have all. Okay, so that's 1, 2, 3, 4, 5, and so 5. So 5 of them, not 6, 5. Did we do it in 5 different ways then? Seems like. And the distinct is only helping us because we did it. So 1, 2, 3, 4, and 5. Yes. So 5 answers are the same. Choose whatever you like. This is an inner join on equality. But that doesn't mean inner join can only be done on equality. The condition could be anything. The title is not equal to the title of the other table. You could do that. Oh, I want to see this is available, this is not being desired. You know what I mean? Like you could do anything. Your where condition depends on you. I've used an equality. It could be any of the relational operators. With title, it doesn't make a lot of sense, but maybe you're comparing 2 numbers. Maybe you're comparing 2 ages. Maybe you're comparing 2 weights, 2 prices. You could say greater than, less than, not equal to, whatever you want. So natural join is an inner join on equality on the same named fields. That's all where you can use a natural join and use it. The rest on, where, commas, whatever you want. Make sense? So this is intersect. Okay. Now the third one, which again is not supported in MySQL, but is there. So the except all says, let's see. Oh, where did the question go? Question is missing. Yes, it is missing. Okay, so please write the question with me. Sorry about that. It is not supported in MySQL, and I would like to answer this query. A list of all job titles that are in job desired, but not in job listing. So people want this job, but there is no listings for it. I want to find out, oh, people need this job. They are desiring it, but there's nothing in the market for this. So it's like a minus. It's here, but it's not here. Or all jobs that are here except these jobs. So that's why it's called an except or except all. Okay. It's not supported in MySQL. I'll write it for you and then I'll give you, then we'll work it ourselves. So I'll kind of pick it from here just because it's here. Except that we'll have to change it. They are in job desired, They are in job desired, but not in the listings. So it's like English, like you were talking in English. So pick up all that is in job desired except in job listings. I know it's not, so I'm not uncommenting it. But I just have to put it in a certain order. So this says that the title is in job desired, but it is not in job listings. And there's another way of actually writing it. Let me write it for you. There are two answers. You have an except and you have a minus also. The word minus also works. And again, the difference between except and except all is will show all with duplicates and without duplicates. Same as in union, okay? It's like a minus job, right? So minus means what? It's here, but it's not here. Now, how do we answer it? If it's not available in, but I mean, it's a common question. There's nothing big in it, right? It could be just asked. People want this job, but they don't find it there. It's not in the listings at all. Think about it now. Can I do it using an inner join? If not, then there has to be some other solution, of course. So how will you what will you say? That they are in the job desired, but they are not in the listings. You want to join the two tables for sure, right? You want to join the two tables. You want to join the first table with the second table. But if you simply say, oh, the titles are not equal, that won't make sense. Everybody will say hello to every other one, which is not. So it's kind of saying programmer is here and not here, but not here could be many other bakers. And the programmer will say hello to everybody who is a baker, a system analyst, or whatever. But that's not what we want. We have to think of some other way. Inner join won't work in it. When you think of it, why will inner join not work? If I say a programmer is in the job desired table, but is not in the listings. So what is the condition you will form? You will say, oh, their titles don't match. But if the titles don't match, the programmer will say hello to the baker. The programmer will say hello to the system analyst. The programmer will say hello to the chef, whoever was listed. That's not what I want, right? So I have to think of another solution. Now that other solution is also a join, but it's not an inner join, right? It's not an inner join. It's called an outer join. Okay, now let's look at the outer join. So there are inner joins, there are outer joins, and then there is a subquery. There are three ways in which you can almost answer every question. Sometimes yes, sometimes no. I can't answer this using an inner join. I can do it. So I have to think of another kind of join. So let me tell you what it is. First do it, show it to you, and then we will go from there. Okay, now let's do it. I'm going to do a select. Again, you can pick up any of the fields, the star or whatever, but my aim is again only to show titles. So I'm only going to show titles. I'm going to show you first a star because it always makes sense to begin where it is and then pick up, oh, what do I want? Okay, so let's write the two tables. The first table was called table job listings. Doesn't matter how it does matter, but we'll talk about it in a minute. Instead of using the outer join, I'm going to use inner join. I'm going to use the word outer join, but outer join comes in two flavors, okay? So I'm going to use one by one. Give me 1 minute. Let me complete it, and then I'll show you what it means. And because they are left and right, the way in which you write your table names matters. In the inner join, it really doesn't matter which one you write first and which one you write second. It really doesn't matter. But here it matters. The word right is different from the word left. Okay, let me just do this one first. Let me tell you what the outer join. Oh. Okay, now the condition. How are you joining? So we are again joining on titles. So now just to show you, because the table names are so big, you can always give them alias names. You know what an alias is, a short name, right? Also known as. I'm just going to call them JD and JL just because they're easy. Then you can kind of write it quickly. So you're saying JL's title is equal to JD's title. I kind of just went with their short names. You don't have to. I'm just lazy. And you should know that it exists. Now, a few things that you have to know. There are two kinds of outer joins, right outer join and left outer join. And an outer join always needs a condition. Always. You can't write it without a condition. And that condition has to be written using the word on. There are no other options. So you will say, oh, thank God, there are not 5 options in here. There is no other option. You can use a right join, outer join. You can use a left outer join. The right outer join is taking this to be the major table. The right table to be the major table. If I change this right to left, this becomes the major table. I'll show you what is the meaning of major, okay? And then it always has to have a condition, and that condition is written using the word on. Now, what is it saying is this. I'll run it for you and then I'll explain, okay? So remember, listings is on the, oh, sorry, desired is on the right and listings on the left, and I'm doing a right outer join. I want to show it to you, then we'll go ahead and do it. Once you understand them, you'll be okay. Don't worry. It's just understanding it for the first time. Okay, now let's look at it. Because I did a star, because I did a star, all the fields come. All the fields of the first table, all the fields of the second table. Now let's look at this right and left thing. When I say right, I'm saying the right table is not more important. It's the master table. What does the master table mean is this. It picks up a record from the table and tries to find a match in the second table. Right? So which was picked up? 10 records. So these are the 5 records. These are the 5 records. 10, 7, 8, 4, 9 are the 5 records in the job desired table. These are the 5 records. It tries to find a partner. 10 found a partner. 7 found a partner. On what? Title. Title match. 8 found a partner. 4 couldn't find a partner. Notice what's in that record which couldn't find a partner. All field values are null. Look at 9. 9 couldn't find a partner. Chef couldn't find a partner. Notice all the fields are null. So now let's understand what a outer join is. Outer join is like a join. But if it doesn't find a partner, it just puts null there. Inner join will only join if it finds a partner. Outer join will say, okay, you are my partner, good. The records get connected. If I don't find a partner, you will see that the fields are filled up with null. The condition has to be given. My condition is title is same. In a right outer join, this procedure is done with the right table, and the right table is talking to the table on the left. Now you will say, how do I decide right or left? Try to work with a table that is smaller because it has less records, so it will do less work. Job desired was a smaller table, listings was a bigger table. So I took job desired to be my main table. I said, you have less records. You said, do you have a partner? Do you have a partner? I can do the same thing. You'll see the same result. All I'll do is this. So notice what has happened. Everybody in the right table has said hello to, if it could find a partner, good. If it couldn't find a partner, it just put null there. Okay. Now let's do the same thing. This is not the answer. This is just showing you how I will find the answer. And I'll do a left outer join. Let's see what happens in left. I've just changed it from right to left. Now, every record of the listings will be taken first, and it will say, do I have a partner? Do I have a partner? Remember in the listings table, there were 14 records. If those 14 records, every time it finds a partner, good. If it doesn't find a partner, then it will put null in the other fields of the other table. Let's see how that works. Now look at the left. Now this is the major table. The listings is the bigger table. It's the master table. Try it. Or try to run both together and you can compare. So the first one, because job desired was the master table and it had 5 records, I have 5 outputs. I had 5 records in job desired and each one said, hello, I found a partner. Oh, I didn't find a partner, null. So I have 5 answers. In the left outer join, there are 14 records in the listings table, and that's on the left hand side. I will have how many answers in my table? 14. If it finds a partner, good. If it finds a partner, good. 13 found a partner, 13 found a partner, but as many times, every record, if it finds more than one partner, it is saying hello to it. 13 said hello to 7. 13 also said hello to 8, right? Then 1 said hello to 10. And then 2, 3, 4, 5, 6, 8, 9, 10. They didn't find a partner. What happened to the rest of the records? None. That's the difference between left outer join and right outer join. Which table is the master table? Got it? Which table is the master table? But that's how a join, left outer join works. Now think of the solution. I want all those records that are in the job desired, but not in the listings. So in a way, I'm saying you don't have a partner. Think of it again. I want to find out all those job desired records that don't have a partner. They're not in the listings. I don't have a partner. So which records should I pick up? I'm going to this because my question is from the desired to the listings. So it's more efficient. Why will I go the other way now? Again, you always have to think, should I go this way? Should I go this way? You have to think about it. Now tell me, which of these records will tell me that they are in the job desired but not in the listings? Look at the nature of the data, of the output. Which records should I pick up now? They are in desired but not in listings. What do you see? They are in the desired but not in the listings. What do they have in their fields? Null. So only pick up those records, put a condition. Pick up only those records where, pick up any field. All these fields are null. Where job ID is null, because job ID is the primary key will do. Title is null, even that will do. Salary is, any of these fields will do, because all these fields are null. So if I add that condition to my outer join, I'm done. I have my answer. Right? So let's now try to write it. So you can put this in comments if you like, just so that you know how outer joins work. But this is not the answer. The answer will be complete once I do something to it, right? And what is that something? You've just told me what is that something. That something is only pick up those records where. Now you can pick up any of the fields, whatever, really doesn't matter. I'll pick up the job ID because it's my primary field. It's always better to work with primary field values. Where the job ID is, only pick up this records. I'll have my answer. Now the star will not, I don't need the star because title is good enough. Because I'm only interested in the title. If you keep the star, I mean, it will show you all records, all fields, but that's not what I want. Make sense? I'm showing you the table. There is the right outer join table. Which records do you want to pick up where this field is none? That will tell me that they are desired, but they are not ready. Okay, so try that now. Now try that. See if you have your answer. There it is. 4 and 9 didn't have partners. Sales manager and chef are the two jobs which are desired, but not in the listings. So now that star is looking odd because I don't want to see everything. What will I say? Title. Now again, title is ambiguous. So pick up the title from which table? The job desired table, because that's your master table. Don't pick it up from this table because here the title is null. Be careful, okay? Here it is important where you are picking it up from. Now pick this up. So I should have chef and sales manager. Oops, unknown title. Did I misspell it? No. Table job desired? No. Unknown column. What the table job desired dot title. Oh, no. If I've given it an alias name, I can still, can I not use the original name? That will be really silly. Oh, that's really strange. Once you have given it an alias name, then you have to use the alias name everywhere. That's not good at all. I mean, I can choose what to. That's really strange. Oh. But anyway, that's a syntax. I can change it. If you give a table an alias name, then you have to use it in your everywhere. That's really odd. Really, really odd. I mean, I should have the option of using either. So now here is my answer. So I've boiled it down to the answer now. So understand that an outer join is different from an inner join because all the outer join does is from the right or the left, depending upon which one you've chosen. It tries to find a partner. If it can find a partner, it joins itself. If it does not find a partner, it still joins, but joins with null. So now you say, oh, you have null in the other table, that means you don't have a partner, so you show the answer. Now, how will you do it in your left outer join? Now let's look at the answer. Let's look at the answer of the left outer join. This is what we had. Okay, this is what we had in the left outer join. So I said pick up all the, so 13, oh, this is going the other way. Can I even do it using I? Okay, let's see if we can do it. What condition shall I say? 7, 8, and 10 have found a partner. Can I do it using a left outer join? No, I cannot do it using this. There is no way from this table I can do it. If I want to still do it using left outer join, I'll have to take this table from here and put it on the left, and take this table from here and put it on the right. Then of course this left is same as the right in the previous one. But from what I had originally, I can do nothing about that. There is no conclusion here. But if I just swap their places, it becomes the same as the first one, absolutely same as the first one. I used right here, this table was on the right. I used left here, this table is on the left. And then the same condition will hold. Yep, then the same condition will hold. So the only difference between right and left is who is the master table. Okay, that's the only difference. You can either of these answers is correct as long as whichever you choose, really doesn't matter. So both these answers are right. And all I've done is look the difference. The only difference is right becomes left, but table is swapped. So the major table is still my job desired table. I couldn't get anything from the previous one. I cannot do this using an inner join. There is no way I can do it. If I say not equal, it won't work. If I say equal, of course, that's not what I want to do. Not equal is not the answer, right? And lastly, there is another way of doing it, which is called a subquery. So I'll say using outer joins. But with outer join, you have to use either right or left. You have to give an on condition. You cannot use the where is not, this on is related to this. How are we joining is on. These extra conditions are doing where. And one more. Let me introduce you to a subquery. Many people find this easy. Much easier because it's more how we think. But the aim is, distinct title, guys. If there is any repetition, then distinct. Otherwise, we are fine. No, there are no. There is no. So if there is, you can always say distinct. Okay. Okay. Now let's look at this one now. If this makes sense. You are saying pick up a title. Query means a query inside a query. Pick up the title from the table. That was the question. But this should not be. But this should not be in the listings. Let's look at this solution now. As I said, many people like to do it with subqueries, but if you read a little about it, you will find that some queries are executed quicker when you use subquery, others quicker when you use joins. So at the end of the day, after maybe 5-6 years of experience, you'll be able to kind of make an educated guess that this will take less time and this will take more, and you will write it. That's all those database programmers do day and night, 24/7. So they are very smart, right? Because they've been doing this over and over and over again. You have to understand that solutions may be possible, may not be possible, and after they're possible, one may be better than other. When I say better, I mean in terms of execution. Now for us, we have 5 records or 14 records. When we're talking about millions of records, then execution time matters. It does matter. Okay, now let's look at this one. This looks very English-like. It says, now a subquery, this is called a subquery because there is a query inside a query. Notice there is a select inside a select. And this is how it works. The sub works first. It says select all the titles from the job listing. What will it give you? All titles from the job listing, right? Now it says pick up those titles from job desired that are not in this list. So you get a list when you do select title from job listing. It's a list, right? It's a list. Think of it. What do you get? You see a list of values. I'm only picking up a field, so it is a list. I'm not picking up more than one field. You have to be careful. I'm not doing a star here. Star will not work here. Why? Because star will be a whole table. You can't look for something in a table. You can look for something in a list. So you pick up the titles from the job listing table. It's a list. And then you say, those records whose titles are not in this list is my answer. So this is called a subquery. And you have to be very careful that you don't put a star here. If you put, so let's do this. And we should again have the same answer. Right? So I'm saying if you only did this, you can do it independently. See? Here are everything in the listings. You're basically saying pick up a list. And then you're saying only pick up those titles from the desired table that are not in this list. Now try to change this one field into a star. Now look at what this returns. This returns a whole table. It returns a whole table, right? Now if you try to do this, it's going to give you an error. It says, I can't do it. This should only be one column. Give me only one column here because I can only I can search the title only in the title column. I can't search title in 5 columns. You'll say, can't you see there is a title column? No, it can't see. It's a dumb machine. It can't see, oh, there is a title column. I should be searching title in the column. It can't do that. So you have to say, search the room on the first floor rooms. If you say, oh, search the room in the first floor, the guy will get confused. Do I also search the washrooms? Do I also search the accessibility rooms? So you have to exactly say, search the classroom in the classrooms list. So you can't use a star in the inner subquery. You have to be careful about that. Why? Because think about it logically. You're getting a table, and how in a table can you look for a value? So therefore, the error says operand should contain one column. So this can only be a column. And now it will work. And let's see it working. There it is. So that's the introduction to inner joins, outer joins, and subquery. The introduction. Union is available, except minus and intersection are not available. Now you have a little idea of what an inner join is and what an outer join is, and a subquery. Now we will start writing more answers. Okay, so I kind of kept this separate because I wanted to show union, except, and intersect, and they were not available, and therefore it was easy to kind of show you one answer each. Now the same script, I think have 15-20 queries more, and we'll start answering. Okay, so I'll put this back on Blackboard for you so that you have it, and then open up the next script now. So I've just completed this, and it is going back in the same my contacts job. I'm going to overwrite your file with my file. And I look for classwork. I just finished it in the classwork. Where are you? February 26th. There it is. And we did a little bit of change in, I didn't do employees from last week, guys. I don't have time, and it's not a big deal. I mean, there's enough of substrings that I did with you. Not substrings, string functions, I mean. So open up the second one and start with me and start answering them. So donations. Okay, so everything I've done till now is up on Blackboard. Okay, let's do the contacts 2 jobs now. As I said, it's not different. It's just because I wanted to do this separately. So it's the same script. It's the same script. We don't need line number 9. Actually, we don't need it. We don't do any updates. We don't need it. But this one, line number 9, is now needed. Okay, let's start. Oh, Oh, spelling of unsigned is wrong. Make that change, please. My bad. I must have changed it afterwards. Run the script and we'll know if there are any errors. There's a spelling error, guys. Make that change, please. Sorry about that. Okay, let's start answering queries. So there are the same tables. I don't know how many do we have. We won't be able to finish all of them. So that's okay. That's our job for the rest of the 3 classes. We are going to live in joins and queries. So sometime on Friday, I'll give you an assignment so that you have today's practice and Friday's practice. I'll give you a couple of days for it because you're going to work in pairs. So you need to be together or Skype or whatever you like, but I'll give you a couple of days and then give you the results. So, okay, let's start. It says select the name, concatenate the first and last name and phone number of all those contacts. So this information is coming from where? Here is where your ERD will be handy. Name and phone number is coming from this table, right? Name and phone number are coming from this table. Let's come back. So we know that the name and phone number is coming from the table contacts who are interested in a computer programmer job. That means this is the job they desire. Where is this information coming from? The job desired table, and are ready to accept a salary of 95,000 or less, right? So remember there were 2 salaries. It's a little confusing, but I didn't change it because it was not my table, but we'll see where we want to put the 95,000. There was a low salary and there was a high salary. So 95,000 or less means they're ready to take a higher salary of 95 or less. So, I mean, I didn't change it. It was too much work again. I'll give you the answer both using joins and subqueries. So I'm doing a practice of both of them so that your assignment you can do together for both of them. Okay, now think about it. The first thing to be understood is what tables are we interested in? That's job number 1, right? So we are interested in the my contacts table and the job desire table. So these are the 2 tables that I'm interested in. You can use inner join, you can use natural join, using, on, where, comma, whatever you like. That's 1. 2. How are they joined is my second question. If I'm interested in these 2 tables, what is their joining field? Contact ID. So this table, the ERD will help you to kind of figure out. So I want to join table my contacts with table job desired. And the commonality in them is the field called contact ID here and contact ID here. They could have been entirely different named fields. But using this relationship diagram kind of tells me that these are the 2 fields that are related. Even if they were called different, you'll see a line between them. And that's what is handy. Therefore, I choose this relationship. So their contact ID must be same. Okay, start writing it, right? So now we know these are the 2 tables. This is the common field. I have to join when they are equal. And there is a condition. The person is ready to take a salary of 95,000 or less. Now, I don't know where to put this condition. With salary low or with salary high? Low says this is the minimum I'll go. And high says this is what I'm expecting. Okay, let's see how to answer it. Because the tables are not mine, though the queries are mine. I'll have to see how I want to answer them. Okay, now start answering with me, okay? And I don't know whether I have, they're no different. The names are no different, but still, just in case we want the names, I have it handy, the names of the field. Okay, let's start. Do the join. Select. What did it say? The name. Concatenate the name. So concat. The name of the fields are first name and last name for your information. Blank in between, or you can use your WS. Okay, now since you are doing a concatenation, we will call it name or whatever you would like to call it. Full name, I'll go name. So that's the first part. Select the name and the phone number. The phone number field is called phone for your information. Usually when you put one display name, you usually put it for all the fields just because it's neater. Not that it is required, it is neater. Okay, now there were 5 different ways in which I had written an inner join using the word natural join, inner join, commas, wheres. You can choose whatever you want. It's up to you. Okay, now the 2 tables. The 2 tables are TBL, my contacts. That's your first table. You can give it an alias name if you want. If you don't want it, that's up to you. If you want to start doing the word inner join in your head and it makes easy for you, go ahead and do inner join. It's entirely up to you. I leave it to you. The second table is the table job desired. Again, alias names up to you. You don't have to say as also. You can just give the alias name, but it's up to you again if you want to do it or you don't want to do it. Okay, here I'm okay till here. I know which two tables to join. On what conditions do you want to join them? You can do on, you can do where, you can do whatever you like. Again, I leave it to you. The joining condition was the contact ID. Okay, so mc.contact ID is equal to jd.contact ID. And I've just found out that once you give alias names, you have to stick with them. Right? We are going the right way. Which tables to be joined, under which conditions to be joined. Okay, who are interested in computer programmer job. Okay, now comes your where condition. So the title should be computer programmer. Now, just because title is a field, which is a varchar field, I'll use a trim function. It's just better to use trim functions with varchar. You don't have to again. It's just a precaution to do, and which is a good precaution to do, a safe precaution. So take your JD's title and trim it. And this should be equal to computer programmer. I think it automatically also trims it. If I'm not mistaken, I can double check. If you try to compare a field with equality and there are blanks on either side, I think it automatically also does it, right? And I'm just going step by step. What fields to choose, which tables to join, which condition to join them on, and any other extra conditions, right? So where the title is computer programmer and are ready to accept a salary of 95,000 or less means if they say, okay, now this I leave, this is my interpretation, okay? It may not be yours. Where the salary low, this person is ready to accept a salary of 95,000 or less. This is my interpretation. He's ready to accept a low of this or less. That's what salary low says. I'm ready to take this low. That's the result. And a semicolon, of course, now. The word inner join, the on, you can have all three where conditions. You don't need a on, then you can say where this and this and this. Was that your question, Zach? No. Oh, you figured it out. Okay. So instead of on, you can put a where there, and then you can do an and. Instead of the word inner join, you can put a comma, but as soon as you put a comma, then you can do on. You have to say where, and, right? So the different formats are up to you. Or I'll do the natural join with you. So I leave it to you. I can repeat this 5 times and I can show you how it can be done. I'll do the natural join with you just because natural join is natural. What do you do with natural join? You don't give the joining condition. The joining condition is automatically this. So if you want to keep it, it's up to you. But actually this is you can do this now. You can do this now in natural join. Natural join automatically joins on equality. Okay? It automatically joins on equality. So you save yourself a line. Or if you're lazy like I am and you don't want to even say the word inner join, you go comma, but then you can't say on, you have to go where. If that makes more sense to you. And you start putting an and. So the first one uses the word inner join and on and wheres. The second one uses natural join, and you cannot give a condition with natural join. It is by default. Same fields equality. The fields have to be named same, which are in our case. Otherwise, you can't use it. And the third one, I'm doing the same thing, but I've used a comma. And then when you say comma, you can't say on. You have to do a where. And there were two more options, which of course you can fill up. You can do using and you can do whatever you like, but it's up to you. You can practice because you're learning it for the first time. And every programmer has their own preference. Maybe in an assignment, I ask you to write it a certain way because I'm checking, because there are just different ways of writing it. But of course, when you work in the real world, in the real environment, it's your preference. So these are inner joins, right? I've done all these using inner joins. Now, what about outer joins? These are saying names and phone numbers of all those people who are looking for a computer programmer and their salary is less than 95,000. Can I do it using an outer join? What am I looking at? Programmers only. So the job desired guys are programmers. Their salaries are this. And I want to pick up the, yep, I can do it. Yep, you can. Okay, let's try it. Hopefully. These are using inner joins, right? Can I do it using an outer join? I think so. Let's try. Okay, so the fields don't change. You still are doing concatenation of first name, last name, name as phone number, whatever. Now here is what I want to change, right? Okay. The right table is the job desired. The right table is the job desired. And that is my master table. That's what I'm thinking, okay? Okay, there. Okay, so pick up records from job desired. On condition remains the same. This should work. I think this should work. Right table. And of course, I can write it as a left outer join. I only swap the tables. Please don't get overwhelmed with all this. I know it's absolutely new, but I've already warned you. This is the most difficult topic in your course. Therefore, it's given 3 weeks. The left outer join and the right are no different except the tables are swapped. See, why have I used a right outer? Why have I used an outer join? I've said pick up a record from job desired. If that person is, so join them in contact ID. And if that person is a computer programmer and he's ready to take 95,000, we are good to go. I think I'm right. Now the whole thing is what is the answer, right? Now the whole thing is what is the answer? People who are ready to take computer programmer and 95. Okay, we know it. Okay. Job desired, there were only 5 records. Executing query. Okay, so no syntax errors. Let's see. Right, the answers are right. Why? There were 2 people who wanted to take a computer programmer job in job design. Remember? Therefore, we saw Baker, computer programmer, computer programmer. So 2 people are ready to take the computer programmer job. And seems like both of them have 95,000 and less. Now that I have to check. Definitely there were 2 people. So the answer has to be 2 or less. What is their low salary? Job desired. Computer programmer. Yep, they both are 95,000 and less. Their salary low. Now, if you change one of these, if you change one to say for the 150K, you change it to 100K, then you will only see one answer. You should only see one answer. But right now the answer is correct. So what did I do? I kind of joined the 2 tables on the contact ID and I said, as long as you are a computer programmer and your salaries are greater than this. Here, the outer joins are better. Why? Because job desired, there are only 5 records and the whole my contacts is a huge database. So I say, you become the master table and try to find out your partners. And here I didn't remove any records. I said, find a partner on the title. As long as you are a programmer, I only pick up those records. So the where condition is telling me which records to pick up. Right? Here the null or the not null doesn't matter because I'm saying the title has to be a computer program. So again, the answer may strike, the answer may not strike, it will take time, but it all comes with practice. Right? It all comes with practice. And I'll give you the last subquery, and then I'll call it a day today because we are at the end of it. So let's write a subquery for it. Please go and look through what we've done today again in class. Please, it's important. So I'm going to kind of copy it. Oops, no, I can't copy anything. This is the only thing I can copy. What I need, right? So the contact, the name and the phone number only are coming from table My Contacts. Now I'm answering the same query using a subquery, okay? Okay, so I want to pick up all those people from my contacts where the contact ID. I know it's not so easy, but you're tired too. So today onwards till the end of the semester, you will have to put in some time in my course also. Till now it was all easy. Okay, so I'm saying only pick up those names. Okay, what am I trying to do? Oh, it's selecting something, that's why. I do an enter and it selects that. Okay, here. So pick up those names and those phone numbers from the table contacts where the contact ID is in where. Where is it? It's in this table. Select the contact ID from the table, from the table, whatever, what was its name? Table job desired. Right? And I only want to pick up those people who are a computer programmer and are ready to take less than this salary. So pick up people who want to be a computer programmer, are ready to take 95K or less, find out their contact IDs, and if this contact ID matches the contact ID from table contacts, those are the people I want. Should again give you Renee and Angelina. Oh, syntax error because I had this extra. Still an error. Oh, JD. Where is JD title? Oops, sorry. There is no JD now. Still unknown. Oh, that JD thing is causing a problem. Copy and paste. I don't have to qualify anything here. There are two tables. There are two distinct tables. And when I talk to one table, I'm talking to its fields. When I'm talking in the select of the second, I'm talking to its field. So you don't have to qualify. You could if you like, but you don't have to. Qualification is always an overkill if not required. But if you like that way of doing it, that's perfectly fine. So what did I do? Look at the 198 to 201 will happen first. So you're trying to find out the contact ID of everybody who wants to be a computer programmer and is ready to take 95 kilos. You found those contact IDs. Now you go to the contacts table and you find those names and phone numbers whose contact ID is in this list. So you get people who want to be computer programmer and who are ready to take 95 kilos. Yes. Okay, so please, before you come back on Friday, please go through what we have done today. A couple of hours, but please go through them because this is all you will be doing for 2 more weeks. And we can't do it more than one. Like I just have to do and do and do more and more and more. That's all I can do to make you practice. But listening will not work. You will have to put in your effort and practice it when you go home. And by Friday, I'll make your group assignment. I'll make that ready, right? So that you can start working on it. Or maybe before Friday also. You have an idea. You may not have all the idea, but you have an idea. Okay? And I'll put this on Blackboard, though it is not complete yet. I'll also put this on Blackboard.